Let me give short organizational remarks. Our forum consists of 4 sessions. At the first session, the participants will discuss the existing possibilities for decarbonization. The second session will focus on future decarbonization technologies that are still being developed. Third session, Ukrainian steel companies will share their plans and achievements in decarbonization field. At the fourth session, we will talk what government policy is needed to decarbonize the economy in general and steel industry in particular. This session, last session, will be attended by representatives of the Ukrainian authorities, and we're waiting for interesting discussion. After the end of official part of forum, we invite everyone to the gala dinner from our general partner Metinvest. It is dedicated to the 30th anniversary of Ukraine, the 15th anniversary of Metinvest, and Day of Worker of Mining and Metallurgical Industry. Detailed organizational information you can find in your forum's program that you have from registration. At our forum, there are representatives of international business, including Austrian. No doubt, Ukrainian and Austrian enterprises maintain close contacts. The ambassador of Austria to Ukraine, Mr. Zernob Fandler, is also present here, and I would like to invite Mr. Zernob Fandler for greeting words. Please, Mr. Fandler.
Dear ladies and gentlemen, dear representatives of the steel industry here in Ukraine and in Austria, dear participants, first of all, I would like to thank you for inviting me to give me the opportunity to speak today. It's a great pleasure for me, even though I have to admit that until not so long ago, the topic that we are going to discuss today was not so aware for me actually. Yeah? But climate change, scarcity of resources, rapid population growth as well as economic growth pose challenges in terms of energy supply, sustainability and climate protection. The global challenges derived from climate change are more topical than ever and show the need for greening the production cycle. Environmental innovations represent an essential approach to mastering these ecological challenges. One of the most important and most ambitious targets of the Austrian government and of the European climate policy is to reach climate neutrality until 2040 or 2050 respectively. This may seem still to be far away, but in fact it is relevant already now. Also, Ukraine foresees a drastic reduction in CO2 emissions with its new greenhouse gases emission target, not to exceed 60% of 1990 greenhouse gases emissions levels in 2030. The Austrian federal government urges climate change mitigation and adaptation in compliance with the Paris Agreement, as well as the strengthening of a sustainable and competitive business as environmental cornerstones of its current government program. Austria, as a highly industrial nation, which needs a lot of energy, the decarbonization of industrial sectors forms a key challenge for the achievement of climate neutrality. The technological transition to green production processes is indeed a major challenge for the entire European steel industry. The key to gradually reduce CO2 emissions in industrial production are innovative technologies. Today's forum is therefore an important step in addressing this challenge. I'm glad that several Austrian companies are represented today at this occasion to share their experience and know-how with regard to decarbonization of the steel industry. Austrian companies are at the forefront in numerous areas of environmental technology, especially in the steel sector. The Austrian environmental technology industry is deeply research-oriented and among the most innovative in the world. In terms of greenhouse gases emissions, the Austrian steel industry is the single largest emitting sector, accounting for roughly 14% of Austrians' greenhouse gases emissions. Voestalpine is currently Austria's biggest CO2 emitter. But Voestalpine is also at the forefront of decarbonization efforts in the industry. Primetals Technologies has been cooperating successfully with the big Austrian steel company Voestalpine in the sphere of environment and sustainability. Voestalpine's new Green Tech Steel program envisages a clear plan for decarbonizing the production of steel. In the long run, the share of green hydrogen used in steel production will be successively increased, arriving at carbon neutral steel by 2050, which is, I think, quite remarkable. Thus, the hydrogen-based fine ore reduction pilot plant developed by Primetals Technologies was commissioned at the Voestalpine site in Donawitz, Austria, and started its work in April 2021. The use of 100% hydrogen as reduction agent reduces the CO2 footprint close to zero. I'm glad that already in the past years, innovative Austrian companies like Primetals contributed to more environmentally friendly production in the Ukrainian steel industry. Some of the exports in that regard were also supported by the Republic of Austria in the form of export guarantees. And I'm even happier that the fruitful cooperation between Austrian and Ukrainian companies in this sphere is already ongoing. A similar partnership like the one between Primetals Technologies and Voestalpine mentioned before as well is now also envisaged with the Ukrainian company Metinvest. I think this is the path that we should further follow, and in this sense, I wish you all a fruitful and interesting conference. Thank you very much.
Thank you, Mr. Fandler. And now I would like to invite the head of the supervisory board of the GMK Center, Dr. Horst Wiesinger. Dr. Horst Wiesinger worked for Voestalpine for over 30 years. For last 20 years, Horst Wiesinger has been CEO of his own consulting company. Please, Horst Wiesinger. Expertise of Horst Wiesinger in the decarbonization issue is invaluable. Dr. Horst Wiesinger support us all these 2 years in this development in field of decarbonization. Thank you, Mr. Horst. Please, floor is yours.
First of all, thank you very much for introducing me. Good morning, ladies and gentlemen. Today's forum is a very important event as it unites all the stakeholders to one goal, the decarbonization of the Ukrainian steel industry. I personally consider this topic at the top priority for the development of the steel industry in the future, and especially in the energy generation, which is a strong link between these two activities. The actual reason for this development, the increase of the carbon use, is the increase of the population in the last 150 years. Since approximately 1900, every 50 years, the population was doubled, and it still will further increase. So we cannot turn the bottom on the population increase, but we have to turn and concentrate on the steel industry and the energy, because the steel industry in the same period of time was increased by a multiplier of 10. The energy consumption by a multiplier of 20 since approximately 1900. So we have the only possibility to turn the button to improve, to decrease the CO2 emission by focusing on the steel industry and especially on the energy generation. We have to understand, however, that steel is one of the most important material, in my opinion, maybe the most important material, which gained vast significance for the society because it's on top of most of the value-added chains in a number of industrial sectors, and which influence overall macro development of the macroeconomy very much. Steel consumption is a clear indicator for the standard of living. Still, approximately 3 billion people on the world are living in areas with low steel consumption, below 30, 80 kilogram per capita, and low GDP. And except Africa, which is outstanding, only shows a steel consumption of 15 kilogram per capita, and everybody knows what does this mean. That's really one of the problem area on our globe. And 2 billion people still have no access to drinking water. Approximately 1 billion people no access to electric energy. So I mean, these 3 billion people will be responsible in the future for increase of the steel production again and the steel consumption. And I think also these 3 billion people deserve this to increase their standard of living. Once more, only chance to reach CO2 neutrality is the technology transition in the steel industry and in the energy generation, beside all other sectors like traffic, etc. My company, Horst Wiesinger Consulting, was already involved in several projects and would be pleased to support the individual companies in this issue. We are proud to be the partner of this forum to share our experience with you. This issue, decarbonization, is extremely difficult for all countries of the world and also for Ukraine. The defined CO2 reduction target of 80% by the European Union can only be met by the full commitment of the global industry, certainly of the European industry, and involving all the communities involving CO2 emitters, which I have some doubts. And I have some doubts especially concerning the global commitment. I'm seeing this with a high risk to fail if not everybody is committed. So, but however, especially, we cannot neglect the strong link, the strong connection between steel production and energy generation. The transition of the energy generation towards renewable energy will be even more important and will be the basis for the success of the decarbonization process. The steel industry is responsible for only approximately 1-digit percentage of the global CO2 emission, and the energy almost around 40% of the CO2 emission. And the Ukrainian shows a factor in the steel industry of around 15%. Carbon-free technologies represented mainly by individual solution and research projects are at the fledgling stage with different status of maturity. In 2015, the Paris Agreement on climate change was signed. Unfortunately, 2 years later, in the 17th, the US left this agreement. The parties on this Paris Agreement agreed to increase the global, to limit the increase of the global average well below 2 degrees centigrade. The European Union is moving towards the carbon-free economy in the framework of this Paris Agreement. The discussion of possible goals, targets for the reduction of CO2, however, my opinion, should be stopped, should be finished. We have to start the implementation, the transition immediately to achieve this challenging target of climate neutrality by 2015 and even 2040. Funding the decarbonization remains one of the key problems affecting the industry. For steelmaking companies, carbonization primarily means a cost in capital investment, and this would be even more valid for the energy generation. And the European Union is will partially compensate these costs as part of the European Green Deal, realizing that this is impossible to implement such global projects without public support, without governmental support. I will not go into detail now and not comment on the different extremely high investment figures which are published for funding this technology transition. One example, if we would transit the 2 days primary steel production blast furnace converter on a global basis, it would cost, based on the 2 days available figures, around 5 trillion euro, where approximately 1 to 1.2 trillion will be needed for the steel industry and the rest, 3.5, 3.8, for the energy transition. And however, I'm a strong believer we should not start such an important challenging development with such feasibility consideration. If you concentrate on the beginning on feasibility, you can kill any future development or lose the reality by applying too healthy arithmetics. The important first target for me is to reach a sustainable technical solution to introduce technologies which are defined. And if the technologies are defined, and for most alternatives they're already far advanced, we can turn, we can turn the button to reduce cost and improve the cost. Why decarbonization is a challenge, and for me it's not a challenge, it's a potential for Ukraine. First, the electric arc furnace production is below 10%, and this will be an issue for the future. The domestic steel consumption will increase because due to the low steel consumption per head in Ukraine, and this will be consequently increase the steel. The steel-related export is responsible for more than 20% of the overall Ukrainian export. Important, the availability of raw material, especially iron ore, is the basis for the competitiveness of Ukrainian steel industry, and especially the vertical integration of mining to the steel production. And one important, and it sounds strange, the equipment of Ukrainian steel and energy industry is overaged, beside all the investments you did in the recent years. And essential investment would be necessary even without decarbonization. And there's a good example from Austria. About 75 years back, after World War II, when the losing countries like Germany and Austria had to restart the business, they had to restart the steel production, but this was practically destroyed. So we had to start this new equipment, this new technology, and this was the basis for our increased competitiveness in the later European Union. So it's a good example that there's a potential. And for the development of renewable energy, solar, wind, Ukraine shows a very positive precondition. So far, the climate and the location is concerned. And also the land is available, because for installing wind, solar equipment, you need land. So this is a very positive thing. What activities should be started and should be done? First, prepare a roadmap for the transition of the iron and steel operation and energy generation. I know that individual companies already work on that and far advanced, but it should be the basis. And due to the fact that there's no single solution available which fits to all, this roadmap for the steel industry should be prepared by each individual plant individually, including certain benchmarks for key success figures. And these key success factors should be the basis for comparison the individual solutions, and especially for decide the sequence of introduction, the amount of support, and very important, you need to evaluate this, the implement of pilot plans and demonstration plan. The roadmap for the energy transition, however, should be initiated by the government with coordination with the end user, like the steel industry. Start transition of the steel industry immediately after defining the roadmap, and I think for most of it, it's done. However, this transition cannot be done in one step due to the different status of the maturity and the available funds. Most likely, I believe, it will be maybe in 3 steps. Step 1, which could start immediately, and it's already ongoing. It's the application of the best available technologies for this, and especially in the blast furnace area, in this front end of the steel production. There's a potential of saving between 20 and 25% of CO2 emission. And in a period of time, let's say the next 5 years. And this can start immediately. The second phase, very important, is the transformation of blast furnace converter route, the basic steel industry, to electro arc furnace direct reduction. It shows a potential of CO2 saving if you apply natural gas for the direct reduction by approximately 40%. If in the future you add hydrogen, it can be drastically improved. Time frame up to the next 10 years. On a long-term basis, a long-term development, we are looking for the breakthrough technologies like hydrogen-based technology reduction, and I have to admit, I'm qualified to talk about hydrogen reduction because some decades ago, my doctor thesis was hydrogen in the steel industry, but nobody took me serious in this time. So, but it's changed a little bit. So hydrogen-based reduction, CO2-free electric power, and very important, carbon capture and storage and use. And this even starts to become important right now. Because I still believe even with all the new technologies, solutions implemented, there's still a high possibility that we will not reach the 2050 goal. An essential portion in the energy, I believe, could still be generated by fossil fuel. And to overcome this problem, we need carbon capture and use. The saving potential for this phase is up to 100%. And the time frame, a little bit more, it's up to 25, maybe 30 years. So, but it's very important to concentrate on this. And the last item, Ukraine should concentrate to investigate in building up a cluster for the production of hydrogen for domestic use and delivery to the European Union. You may be part in this time already of this union. The structure for generating electric energy in Ukraine shows already a high percentage of CO2-free production, which will be even improved by further increase of the renewable energy production and modernize the outdated power plants. This could be, in my opinion, a strong point, a serious point for cooperation with the European Union, because also the needed pipe net is available. And you have to know that the hydrogen pipe net can transport 10 times the energy at 1/8 of the cost compared with electric transmission lines. So it's very feasible. This could, and that's why I'm a strong believer we should concentrate on this, create a win-win situation between Ukraine and the European Union, also for joint funding in the future. My conclusion, I appreciate the politics and the industry join hands, especially for providing the funds based on the importance and priority of this topic. It's not normal. It's very rarely that such a close handshake is available. However, as already mentioned, the priority for me is to find sustainable technical solution. And this demands a drastic increase of the capacity in engineering and natural science in the industry and in the universities. The creativity of our engineers and scientists will become the most important resource of a country to solve the upcoming problems, and this is even more important, in my opinion, than the funding of the projects. Thank you. I don't need it anymore.
Okay. Thank you, Herr Wiesinger. You are not only dreamer, you are a man who modernized with your hand steel industry. Thank you. We have seen. So, in this session, at the first session, as I talk, we will talk about decarbonization technologies, which are available for implementation right now. In this session, will be 4 presentations of market leaders. 3 of them will be offline with us, and 1 of them will be online. And I'm very glad to invite on our floor, please, Norbert Petermeyer, Executive Vice President for Sale and Marketing in Prime Metals Technologies, please. Alessandro Martinez, Vice President of Danieli Centro Metallics, please. Jan Bader, General Manager, Steelmaking Metallurgy in SMS Group. He is online today with us. I know he's online. Everything okay? And Oksana Roman, Energy Transition Leader at Bilfinger Tebeden in Central Eastern Europe. I have seen, and I hope she will come in 1-2 minutes. So we start with Prime Metals. Is one of the world leader in engineering equipment, supply and services for steel industry. Company is involved in the following decarbonization project like I3 upgrade to steel, High 4 and other. And now I would like to give a word to Norbert Petermeyer. Your 15 minutes and presentation, please. Oksana, please, we're waiting also you.
Thank you very much, Stanislav, for the introduction. Welcome to everybody here. I'm very pleased having the possibility to make a short presentation to all of you about the status and situation of prime metals technologies, what we are doing on the market already with this very important matter, decarbonization in the steel industry. I just can tell you that we are already very active since some time on this subject, and me personally, I'm traveling around the globe actually also in these difficult times with COVID, because this subject is really, it's not limited geographically to Europe, it's a subject which is really a global one. And sooner or later, for sure, it will also touch the Ukrainian steel industry, and also in Ukraine, the producers, steel producers, will have to adapt to the new situation which is coming up in this area. I would like to start with a global perspective about the situation when we are talking about decarbonization. Of course, we are always referring more or less to the Kyoto Protocol, which was started with the CO2 emission measurements from 1990, where we had on a global side, we had around 23 billion tons of CO2 emissions in the globe. This was increasing up to the year 2019 to 36.4 billion tons of CO2 emissions, and the perspective for 2020 is there will be a slight reduction of close to 7% to 30, a little bit more than 34 billion tons of CO2 emissions, which is of course due to the fact that we had last year the consequences of the COVID crisis around the globe. What Mr. Wiesinger and the ambassador already mentioned, there are clear targets, and many countries around the world are already pledging carbon neutrality. The target of many countries, including European Union, United Kingdom, and Japan, is 2050 to reach carbon neutrality. China is talking about reaching that target in 2060, and hopefully with the new Biden administration in the US, also the US is likely to enter this club and also come back to the Paris Treaty, and to have also the target of carbon neutrality in 2050. When we are talking then about decarbonizing the steel industry, everything of course is also linked with the global target of the IPCC in order to limit the temperature increase until 21,000. And in order to reach these targets, the emissions from the fuel fossils have to be reduced drastically from the mentioned already 37 billion tons in 2019 to less than 10 billion tons in 2050, and a further reduction to reach net zero emissions in the year of 2070. These are the borderlines in order to keep our climate in such a way that also our children, grandchildren, and their children will have also a nice environment where they can live in and enjoy their life as we were used to do it. As you probably know, the iron and steel industry is the second largest consumer of energy after the chemical industry. And of course, energy is also, as Mr. Wiesinger already mentioned, one of the major emitters of CO2. The iron and steel industry, on the other hand, is also the second largest emitter worldwide of CO2 after the cement industry. And it's also clear that in the iron and steel industry, the emissions are considered hard to abate. It's not an easy target what we have to taking up, and it's a big challenge also for us, Primetals, as a technological company to get up with this. The iron and steel industry itself is responsible more or less for around 10% of the total global CO2 emissions, which means it sums up to around 3.7 billion tons. And this includes, of course, direct and indirect emissions, which means also the energy which is necessary to produce steel, and emitting CO2 is considered here. When we then are talking about these targets to be carbon neutral in 2050, this means for the steel industry that the CO2 emissions should be reduced by 55% from the 3.7 billion tons to below 1.7 billion tons CO2 emissions, which is, of course, a huge challenge to achieve, and everybody started already working on that. And when we are talking on 2050, it always looks like far away, but in reality, it's really not far. Time is passing very fast. And when we are talking here on short term, we already are starting with many clients actually to talk about projects when they know that at the end of this century, of this decade, they have to replace, for example, a blast furnace by a direct reduction plant. The planning and the project finally has to start already, considering then the erection time. So time is really running fast, and 2050 is coming for sure much faster than we all believe. What does it mean also with respect to the process routes that we have in the steel industry? We have today around 28% of the steel is produced via the EAF route or the direct reduction EAF route, and 72% is still produced via the integrated blast furnace route. There will be a change for sure in this distribution. The integrated route will be reduced, and the electric arc furnace route and the direct reduction EAF route will be increased drastically. Today, the estimations here are around 57% for these less CO2 emission routes compared to the integrated route. So what we have already heard is there is a huge challenge, there is a huge pressure on the political side, of course, from the society itself. In Europe, the European Union already has taken the decisions to go very clearly in the direction of carbon neutrality. But what is happening on the other side with respect to investors and producers and other parts of the society? It's very interesting. The Financial Times had an article in February this year where they are talking that a race against time is on to develop low carbon versions of this strong and versatile material, meaning of course the steel, which is very clear. McKinsey company, the consulting company, stated that there is also a growing investor and public interest in green steel, and this I just can confirm. As I mentioned before, we are in contact with many clients. There are many very interesting projects which are ongoing, and many very famous companies are already entering the marketing with green steel. Major automotive companies in Europe, Mercedes, Volvo, Volkswagen and so on, they are making participations in the first really fully green steel project, which is going to be established in Sweden, where also Primetals is taking part, and there are a lot of very interesting projects which for sure also will be realized, because there is the need from the society and the direction is already given. On the other side, very interesting also Larry Fink, which is the CEO of BlackRock, which is one of the biggest investment funds in the world. He, in his CEO letter, what he sent last year to many CEOs of big companies, also stated very clearly that climate risk is investment risk. What does it mean? It means that also big investments fund, they will have a very close look to the companies, how they are dealing with the environment, how they are taking care of the climate change, and of course this direction where to put the money will have also a big influence on the companies which are dealing in that area. On the other side, we have the producers which also have to deal with the issues. ArcelorMittal, for example, already said that they are seeing the rising demand for the green steel, low carbon steel from the customers, which is very clear. As I said before, the big companies are starting marketing already with clean steel. But on the other side, there is also a huge cost involved with the transformation to green steel, and Arcelor is estimating an investment of around 40 billion tons up to 2050. And in the same range, actually, POSCO, one of our clients in South Korea, also have published figures that they count to spend up to 40 billion euro for being able to make this transformation to green steel. ThyssenKrupp, on the other side, they are estimating investments of around 10 billion euro. And ThyssenKrupp is also a company, for example, which is already very actively working in this area, and we are also supporting them together here. And I think quite soon, actually, ThyssenKrupp will be one of the first companies then which probably will build up and set up a direct reduction plant in Central Europe. So we have different options on the short run, which are already available. Actually, I will give you a little bit of overview about here. Just for everybody to have an idea what we are talking about. We have in principle 4 main routes for the main process routes for the production of liquid steel. The first one is the traditional integrated blast furnace BOF production route. And in this production route, the CO2 emissions per 1 ton of produced liquid steel is almost 2,000 kilos. Yeah? In detail, it's 1,944 kilos, which is extremely high amount of CO2 per 1 ton produced liquid steel. Today, by far, the lowest emissions for steel production is via the scrap EAF route with only 130 kilograms per ton of liquid steel. And then we have the direct reduction EAF routes, depending on the reducing agent which is used. If we have natural gas, around 577 tons of kilograms, of CO2 emissions is produced per 1 ton of liquid steel. And if we change the reducing agent to hydrogen, then we come down to 200 kilogram per ton of liquid steel. So there are really big differences, and Primetals technologies, as also Mr. Wiesinger mentioned before, we have already technologies available which can be immediately used for existing plants, where depending on the actual status of the plants, quite sustainable CO2 reduction can be achieved when we are talking on the agglomeration side for pelletizing plant, coke plants, sinter plants. We have technologies available to reduce CO2 emissions up to 25%. For the blast furnace, there are technologies available already to reduce up to 20 to 40% CO2 emissions, and at the BOF plant 15 to 25%. So these are really technologies which are already working. These percentages depend on the actual status, what is already being done in the diverse steel plants. But of course, considering the actual CO2 certificate prices of more than 50 euro every ton of CO2, which can be reduced for the steel producers which have to buy the certificates on the market, is a win-win situation.
Please, Norbert, 2-3 minutes more.
Yeah,
okay, thank you.
I'll try to speed up a little bit. We have a very good example is our Meros waste gas cleaning system, which is especially for sinter plants. There's a lot of benefits for the clients, and we have built up a lot of references already in the last 4 years. We started up 4 plants, and the last one this year in ArcelorMittal Italy, now Acciare Italia in Taranto. And just last week we signed another contract with Acciare Italia to build another Meros plant together with the Denox plant in Taranto. We also have solutions for near zero emission technologies for the steel industry. The projection here is that for 2050 the carbon capture and storage capacity will be around 400 million tons per year for the steel industry. We also project that 8% of the steel production in 2050 is likely to be produced from green hydrogen, direct reduction EAF route, and the total hydrogen use in the steel industry will grow to approximately 23 million tons per year of hydrogen, which means on the other side, in order to produce that amount of hydrogen, a tremendous amount of 720 terawatt hours of energy is necessary. And just to have an idea, 720 terawatt hours of energy is 60% of the today's usage of energy in the steel industry worldwide. So the energy side is a very important side here also. Of course, Primetals Technologies, we are also licensee of Midrex technology for more than 30 years, and we have built most plants around the globe together with Midrex. The Midrex process is very flexible regarding the source of energy. The Midrex plant can be operated from 0 to 100% with hydrogen, and a Midrex plant which still is being built to be fed by natural gas can be easily be transferred to use 100% nitrogen. This is comparison of the CO2 emissions of the different areas, a comparison of the direct reduction plants with the blast furnace process. When we take the Midrex natural gas technology from today with iron ore pellets as feed, we see that the 60% less CO2 emissions compared to a blast furnace. When we go to the reducing agent of hydrogen, then the reduction is already more than 90% of CO2 emissions compared to the blast furnace, and the same is valid for the HYFOR plant. HYFOR means hydrogen-based fine ore production. This is the latest development from Primetals Technologies, where we have set up a pilot plant in Donawitz site of Voestalpine this year, and tests have been started. And the big advantage here is that the feed is not anymore iron ore pellets, but iron ore concentrate, which means that one agglomeration step, the pelletizing plant, is not anymore necessary, and CapEx would be drastically reduced for our clients. This is an example. Just in February this year, we have signed a contract with our client Metallo Invest in Russia. We will build the world's biggest HBI plant in Mikhailovsky Gok, more than 2 million tons, 2.1 million tons per year HBI production, and the plant is also foreseen once green hydrogen is available to be changed to 100% reducing agent of hydrogen. Very interesting project, and of course we are talking to many other mining companies in order to talk with them about such examples to produce green HBI, which can then be used in the steel plants. But we are also active in carbon capture technologies. We are, of course, as we are a 100% subsidiary company of Mitsubishi Heavy Industries, and our mother company, MHI, they are active in carbon capture, and they have in many years developed the Kansai Mitsubishi CDR solution, which is able to capture up to 500 tons of CO2 per day, and in total a potential of 88% of CO2 reduction is possible depending on the source of the capture. But not only carbon capture, also carbon utilization. We are active. We have here cooperation with LanzaTech. LanzaTech is a company from the United States, and they have developed a biofermental process where we are producing bioethanol, and the first plant of this we are at the moment installing on site of ArcelorMittal in Ghent in Belgium. We will produce there 64,000 tons of bioethanol per year, and the cooperation is between LanzaTech, ArcelorMittal, Primetals and E4Tech. And we will start up this plant still this year in 2021 and come to full production in 2022. This process is fully running. It's this first one in the steel industry in Europe. However, there are already 2 projects running in China and also in other industry, in refineries in other countries like India and so on. So the conclusion, what I have said, the major global economies, they have pledged and are still pledging net zero emissions by mid of the century. The trading schemes and the carbon taxes, which will go together with that decision, they are on the rise. So that is also the reason why finally the Ukrainian or other countries outside the European Union will be fully touched, because of course we know that carbon-free or green steel production will be more costly than the production of today. So the politics in Europe will be very clear that any type of steel which is not produced in the green way and are going to be exported to Europe will be subjected to taxes and carbon taxes. That is a very clear way what we are going, and for that reason, if Ukraine wants to export also in future to European Union, they have to also look how to make the steel greener. In the light of this, the major steel companies have announced carbon neutrality also by mid of the century, and as I said, for us as a plant builder and technological company, this is a huge challenge, but we already ready to take this challenge. We are committed to push innovation and provide reliable solutions for low carbon steelmaking. We do this by improving material efficiency, by technological improvements, by full switching and development of near zero emission technologies. We have we are working on stepwise approach because, of course, it's very difficult and costly to do everything at once. But Primetals Technologies, we are, of course, one of the leading technological providers for the steel industry, and our focus at the moment is very clearly on the decarbonization of the steel industry. All our engineers, most of our engineers are working in the development of new technologies in order to support our clients and give you the right hand for these challenging times and to support you. So that was it from my side, ladies and gentlemen. Thank you very much for your attention. If you have any questions, please.
Thank you, Norbert. It was very interesting and systematic. Please prepare your questions for Q&A, dear guests. And now Alessandro Martinez from Danieli has the possibility to tell us about DRI and hydrogen, about expertise of Danieli. Danieli Group specializes in the supply of equipment for the steel industry. Company offer different solutions to improve energy efficiency, reduce harmful emissions, and Danieli is involved in the decarbonization project like GISH and Ash to Future. Please, Alessandro, it's your 15 minutes.
Yeah, thank you. I think that actually I have only 3 minutes left.
No, 15.
Okay.
Everything okay. Everybody has 15 minutes.
Okay, thank you very much. Thank you for invitation. I will try to be quick, let us say. It is true what it has been said in this conference. The decarbonization is a problem. Actually, I was impressed. I was in a conference in Venice University 1 week ago, and a professor said that 800,000 years ago, the level of CO2 in the atmosphere was 150 parts per million. And it remains like that, for example, 200 or 100 parts per million for millions of years until we came to the Industrial Revolution. And in the last years, in the 1900, this level went from 200 to 400 ppms. And it's still increasing, and the speed is increasing. We cannot sustain this way of increasing the level of CO2 in our world. It's not only the effect on the atmosphere, the effect is also on the seas. The oceans are getting more acid every day, every week. So we are destroying our world. We have to do something. So being practical people working in the steel industry, we are used to put the hands on the things. We want to propose something, and not just to speak about theories, but to show you that something can be done from tomorrow, from today, actually. So, okay, the key pillars are, of course, carbon avoidance, carbon capture and reuse, and energy efficiency, because we are wasting a lot of energy, and also we are wasting a lot of material. So. It's bad to say, but we have also to reduce the consumption of steel per capita, which is something that in the Western countries we already do. It's not done in the Eastern countries yet, but we hope that they will do it soon. So circular economy, water conservation, all this is part of what we can do. But let us tackle the first point, the carbon avoidance. So what we can do in the steel industry to tackle this problem? Well, one thing is to use alternative processes which are already in place. For example, the direct reduction. And then the direct reduction with natural gas is a well-established technology, is already in place in different parts of the world. More or less 100,000 tons of this material is produced in the world every year, so there is nothing very, very new in that. But the new is that if you pass from the blast furnace BOF-based production to the DRI electric arc furnace, you already accomplished half of the steps that you have to do, because, or more than half, you have done 2/3 of the steps. because you pass from 2,000 kilograms per ton of steel to 500 kilograms per ton of steel. So the targets of the European Commission for the 2030 could already be achieved with existing technologies. Then, of course, use of hydrogen and other things can be adopted. I will skip this slide just to gain some time because we already said something about that. I want to focus a little bit more about carbon capture. As you know, Danieli, together with another Italian company, Tenova, we own a process of direct reduction which is named Energiron. It's an inheritance of the old HYL process that in the last years, from 2006 to today, we are jointly developing and promoting on the market. This direct reduction process has intrinsically one important thing. The capture of the CO2 is already an essential part of the process. So in this process, all the CO2 that is circulating in the process gas is captured in different ways with amine washing or with physical pressure swing absorption, etc. And this CO2 is pure CO2 and can be used for different things, for example, for storage underground, for enhanced oil production, for food and beverage, etc., etc. We will give you some example of how our customers are already doing something with the CO2. So starting our task from the present day situation, for example, Ukrainian market where blast furnace is dominant, for example, but in all Europe it is like this. Actually, my colleague was mentioning about the ratio of electric arc furnaces to blast furnaces all around the world. And we said also that the Americans are not so keen to work towards the decarbonization of the steel industry, but the Americans, 50 years ago, they were producing the steel 70% via blast furnaces. And nowadays they are producing 70% of the steel via electric arc furnace. So they did something. We Europeans did not do the same. So we have to move. So in any case, 50% of the step can be done via DRI plus electric arc furnace. Then if you capture the CO2 with, for example, our system, and you do something with the CO2, even continuing using natural gas, then you go down to minus 67% of the emissions. And then if you use hydrogen, etc., you can go down to almost zero. I said almost zero, not zero. Why? Because steel is a solid solution, they taught us at school. It's a solid solution of iron and carbon. So we cannot avoid carbon in steel industry. Some carbon is necessary. So yes, we can avoid completely carbon in the direct reduction, for example, but we need to introduce carbon in the melting of the steel. Otherwise, we don't obtain steel, we obtain hot metal. And with hot metal, we cannot do what we want to do with all the quality of steel that we need to produce. So what are our customers doing with the CO2 that with the Energiron process we make available? For example, the oldest plant that is operating the CO2 absorption system is in Monterrey, in Mexico. Actually, there are two plants in Monterrey, and they sell the CO2 to Praxair to make Coca-Cola. So the bubbles of the Coca-Cola you buy in Mexico are done with the CO2 captured from an iron-producing plant. Okay, so that's a specific smell of iron of the Coca-Cola comes from there. In Mexico also they use for other beverages. In Indonesia, for the food industry, dry ice, conservation of things like something like this. In India also they do, in Salav, in JSW, they do dry ice. In Emirates Steel we have two big DRI plants. Each of them is producing more or less 2 million tons per year, and they are coupled with electrical furnaces using 100% of DRI. All the CO2 is used to inject into the oil wells to increase the production of the oils. We say it's not a very good example because we use the CO2 to increase the production of oil to produce more CO2. Okay, but well, they are making use of this CO2. Nucor in the USA, they sell the CO2 to Denbury Resources, and it is injected in the local CO2 pipe, which is collecting all the industry emissions and then pumping underground, so sequestration of CO2. And all those companies make money out of selling CO2. So it's not only a cost, it can be also a byproduct that can be sold for money. Well, of course, there are other side effects in switching from blast furnaces to direct reduction plus electric arc furnace. All the pollutants that are typically concentrated in the coke making are cancelled with the direct reduction because you don't need coke. So, I mean, apart from CO and NOx, but also volatile organic compounds, the aromatic emissions like benzene, toluene, xylene, and etc. are reduced by almost 100%, and so this is also a contribution to that. Now, all the world is speaking about hydrogen, and of course, as we learned before about Midrex, also Energiron is ready to use hydrogen. Actually, due to the situation, the typical configuration of our process, hydrogen utilization is even straightforward because we have a gas circuit which is reutilizing the top gas exiting from the reduction of the iron ores, which is not completely used because of chemical equilibrium. And we firstly remove water, but just condensating it, cooling down the gases. We subtract the CO2 via the amine system, as we explained before. Then we compress and recycle, and we need a makeup. And this makeup can be done in different ways. We can do it with an external reformer, steam reformer. We can do using coke oven gases. We can do via coal gasification and use the syngas produced with coal gasification. We have plants like that. And we can use hydrogen, why not? Hydrogen, by the way, is even easier to be used than CO as a reductant. And Dr. Wiesinger can probably explain something from his doctoral thesis. The kinetics is much quicker, and the fact that the reduction with hydrogen is endothermic makes less dangerous the reduction for what is concerned to sticking, melting, sintering, etc., etc. Well, to make it short, we are already applying these technologies. The United States have funded a research with the Department of Energy in which we are present. Also, Festalpine is present via the Texas plant in this research. And the idea is to develop a concept in the United States that use renewable energy to produce hydrogen, to produce steel with minimum emissions. But also this is something we are proud of. Hybrid is a collaboration of SSAB, LKAB, and Vattenfall in Sweden. This country has a lot of green electrical energy. Actually, they don't know what to do with the electrical energy in excess. During the night, they are paying Germany to consume electric energy. So they decided, instead of paying for consumption, to produce something that can be stored. You cannot store electric energy like that. So they started with the idea, we transform the electric energy to hydrogen, and we store hydrogen, which is a good idea because they can use hydrogen in the peak consumption moments, even, for example, to produce electric energy back from hydrogen. But then they had also another idea to transform their steel industry using hydrogen, since for them hydrogen is cheap because of this reason. And together with Danieli and Denova, they built a pilot plant in hybrid in Sweden, close to Luleå, and they tested the operation with 100% hydrogen because they wanted to see if all the theories that we producers of plants, plant makers, are spreading all around the world are true. And actually, they prove that there is no negative consequence in using 100% hydrogen during the reduction of iron ore. Next step for them will be to install a DRI plant of the size of 1.6 million tons per year, and we will do together this project, this dream project, in the next 2-3 years from now. Another project for which we were named the best available technology is SALCOS, which is Salzgitter low CO2 steel making. In Germany, of course, they have this idea to install zero carbon DRI production coupled with the melting process. And well, as I told you, this is more or less the trend in Europe, which must be supported by the public sector, because otherwise no steel producer, the first to install this technology alone, will die, because competitiveness is not, of course, possible nowadays, because hydrogen cost per kilo is in the range of 4 to 6 euros per kilo. And if you consider that you need more than 50 kilos of hydrogen to produce 1 ton of DRI, you end up with hundreds of euro of production cost due to hydrogen. If you compare with natural gas, even in Europe, it is 10 times more. So something has to be subsidized, of course. But in the next future, when carbon tax will reach in the range of 100 euro per ton, and when the new technologies will make available hydrogen at a level of 2 euro per kilo, then we reach a balanced situation. Of course, all the world should go in this direction. Otherwise, some protection of the borders must be applied to protect us against maybe Chinese or other producers that will not adopt these solutions. Ukraine is part of Europe, no?
Thank you.
Okay, so let us go a little bit quicker. We have also one important project in Russia. OMK has ordered us more or less 1 year ago a new direct reduction plant for 2.5 million tons per year. It will be hot and cold DRI, ready for the implementation of hydrogen. They will also pursue carbon capture. They want to liquefy part of the CO2 and use it for different scopes. And it's a very important and challenging process. And we hope we will be able to replicate this project in other places in the Russian region. And I had some more slides about other solutions that we prepared for utilizing green energy, like, for example, the new technology of our digital melter with the Q1 so-called electrical part, where we get rid of all the old technology based on the, let us say, static var compensator, SVC, etc., passing through direct current. Why is it important? Because typically what you obtain from renewable energies sources like solar panel, etc., is direct current. Then you have to transform in alternate current. But in this system, you can use directly direct current. Maybe we can speak in detail personally if you're interested about that. And this is already installed in different places all around the world, and is working properly. These are the last references of our Q1 melting system. And of course, there are other areas, like, for example, the reheating furnaces, where you can avoid using fossil fuels. You can use electricity and induction heating, and of course the futuristic hydrogen burners for the same reason. But I believe that it is a waste to use hydrogen to burn in the reheating furnaces. Much better to use induction heating, because it's more efficient and much less expensive. And then something even more futuristic, in our plant in ABS, where we produce special steel, we installed a pilot plant to see if it is possible to use the nature to capture the CO2. So we installed a very big installation for producing algae, spiruline algae, which can be produced. This microorganism, they eat CO2 and other things, and then we can produce food for animals, we can produce medicines and also cosmetics for the ladies and for the men also. And we have just started this experimentation with good results. We are still producing kilos per day, but we think we will increase the size of this green example of utilization of the steel melting technology. Okay, other things, recovery of low-grade heat. You know that typically the water in the cooling systems is, the heat contained in this water is dispersed in the ambient because it is at too low temperature to be useful. Yes and no, because you can install Rankine cycles to produce electricity using organic components as a thermodynamic cycle. So we have done it in our ABS melt shop, and we are producing with some efficiency electric energy starting from the waste energy of the water cooling system. Some 1 megawatt of power is recovered. And also we can do something because, you know, slag treatment is another area where we neglect that there are possibilities. But for example, if you have to calcine the CaCO3 to produce CaO for treatment of the slags in the electrical furnaces, you emit a lot of CO2. So why not to recover the white slag, for example, of the ladle furnace and use it back into the electrical furnace? We are doing it. We are now making briquettes out of the white slag that can be used, replacing 30–40% of the lime that we inject in the electrical furnace. So, okay, this is more or less a synopsis, a resume of what can be saved all around a big steel plant, applying different technologies. Of course, the iron production is the big contributor, 1,300 kilos per ton. Then the electrical furnace. All this is compared to the standard blast furnace BOF route. And every piece of the technology can give its contribution. And it's important that we work all in this direction. And thanks for the attention.
Thank you, Alessandro. Your presentation could raise a lot of interest. I think many people will ask you in coffee break about more details, and I think we all have a very good possibility to communicate and networking here. Thank you that you are coming. So, and now I would like to pass the word to Mr. Jan Bader, SMS. He is online with us. It's possible to connect.
Good morning. Can you hear me?
Colleagues?
Can you hear me?
Yes, of course. Yes, of
course. I can hear you.
Yes, perfect. So, SMS Group is a supplier of equipment for the steel industry. Company develops various technologies, including those related to energy efficiency, recycling, hydrogen, and emission reduction. Please, Jan, we will be happy to hear in your 15 minutes.
Okay, can you see my screen?
No, we don't see your screen, please. Always like this. We will wait a little bit.
I hope this will work now.
Oh yes, we see. Thank you.
Okay. Very good morning. At first, very good morning from Düsseldorf, from Germany. I'm very happy to be a participant of these talks and giving me and the SMS groups the opportunity to introduce also one, let's say, milestone, one technology for this new green steel world. I like to present today something, let's say, some milestones, some new technology inside the integrated route. This is called primary energy melter technology, so-called PEM. You can see the PEM technology here in the picture on the right side. Of course, this will be also the same topic like my previous like this previous speaker from today. We're looking for quite deep CO2 taxation, and be looking for improvement of environmental regulations and require a significant cut in the greenhouse gas emissions. So the primary energy melter is a scrap melting furnace, let's say a technology based on oxy-fuel burners. The PEM provides liquid scrap, and this can be charged in the converter process. Or as a second application, we can use it also for a conventional electric arc furnace. The concept you can see on the left side is that the scrap is continuously charged from the top. The scrap is then melted by the oxygen fuel burner and continuously charged in the system. There are two opportunities, as I said. There are the opportunity for the BOF, and we can use the BOF to let's say to have higher capacity, or we can use this as a substitution of hot metal, and with this to reduce the CO2 emissions. We did this. Let's say the development of this technology with our partner ArcelorMittal in Ghent, in Belgium. On the right side, you can see the plant in Belgium in operation. The test was started some years ago, but the test was at the beginning quite challenging, but at the end we finished everything, let's say, quite successful. So we are confident to use this technology in the integrated BOF plant route. Here I have some results from the test campaign in ArcelorMittal and Ghent. The scrap which was filled in has a yield of more than 92%. We used for the let's say liquefying of the scrap natural gas with the amount of 50 cubic meter per tons and oxygen. An outlook which we can clearly see is that for the future we like to use natural gas, but we can also use gas which you produce in the integrated steel plant, like coke oven gas. Besides that, under these let's say operation, we also checking the NOx formation, the dioxin content in the off gas, and everything was within the allowable limits. And this shows us that the PEM, the primary energy melter, is one opportunity and a very efficient way to provide liquid scrap, liquid ferromaterial for the downstream use in order to substitute hot metal with a high load of CO2 emission. Here, I like to show you two possible scenarios for the usage of this liquid scrap in the converter process. One is, as I said, the addition of liquid scrap to boost the production if you have limits in the blast furnace process. And the second opportunity is to replace the hot metal in order to reduce the CO2 footprint. First application you can see here is the boosting of the production based on higher raw material input. And we're talking here about a possible 20% increase of the production based on conventional converter process. This figure is with the given situation of the same tapping weight. The second application is the replacement of hot metal, and out of that, the substitution of hot metal by the liquid scrap. We're talking here about an increase of 35% of liquid scrap. So we can reduce the hot metal by around 35%. If we're using liquid scrap instead of the hot metal, in the same time, we will increase the overall production in addition up to 8%. This was the results. This was showing in the results of our plant in Ghent. If you're calculating this process and compare this with the conventional BOF process with hot metal and conventional cooling scrap, or even DRI as the input material in the BOF process, we're talking about the substitution and the reduction of CO2 in the amount of 25%. This is, from our perspective, a technology, an intermediate technology on the way to the zero CO2 world. But this is a simple technology which you can use in the integrated plant route without a high amount of capex. A second option, which we have developed, is the so-called PEM electric arc furnace. This is specially designed for weak electrical grids. We're thinking about areas in the world where you have a very low electrical power and where you can substitute the electrical power with natural gas and oxygen. So we will have the opportunity to install, besides the electric arc furnace, a PEM shaft system, liquefy the scrap, and just superheating and conditioning the steel in the electric arc furnace. I coming already to the conclusion. PEM is one step to influence in a very positive way the emission of the greenhouse gases. This is, of course, let's say a transition technology from the world of today down to zero emission. But this is a technology which can be used very quickly in the integrated BOF route and in the integrated in the BOF process. Both opportunities are possible. We can use the PEM process for the BOF and for the electric arc furnace. Thank you very much.
Thank you, Jan, for your very interesting presentation. It's interesting technology. As we thought, we now speaking about technologies that can be used right now. And please don't leave us. We will have a little bit time for Q&A session.
Yes, of course.
And now I want to give a word to Oksana Roman. As I told, she worked for Bilfinger Group. Bilfinger Group implements projects in Europe, Middle East and USA. Companies specialize in improving energy efficiency, applying new technologies for generation of renewable energy, green hydrogen production and carbon capture, utilization and storage. Please, Oksana, floor is yours.
Good morning, ladies and gentlemen. I'm really excited to be here, since honestly, just several years ago, we couldn't imagine such a discussion here in Ukraine. And as today's event is hosted and initiated by the world-class metallurgy companies, this provides really a lot of optimism to reduce industrial footprint and to leave cleaner planet for our kids. So, today's event is hosting a number of reputable technology experts, which provides me an opportunity to focus exclusively on business and very practical aspects of decarbonization project planning and implementation. To briefly introduce our company, let me say that Bilfinger Group has been deeply involved in energy transition topics, in energy transition projects for many years. And the group of companies is operating under the so-called 2-4-6 concept, meaning that we've got two key service lines, being technologies and engineering and maintenance, operating in 4 regions globally, in continental and Northwest Europe, as well as in the North America and the Middle East. And we are serving the clients in 6 key industrial domains, including metals and mining sector. The core portfolio and strategic services of Bilfinger Group perfectly fit the needs of energy transition and decarbonization, and we are proud to say that we've got a wide portfolio of projects implemented for our clients in the domains of carbon capture, hydrogen, wind and solar, energy efficiency, and many others. Overall, our group of companies supports investment projects and business needs of our clients along the entire projects and assets life cycle, starting with the strategic input, with developing or verifying investment scenario, catching up with engineering, process engineering, project and construction management, and ending up with the assets commissioning or decommissioning if your business needs require that. But let me stop at this point and switch to the very key topic of our discussion, which is the way towards decarbonizing metals and mining sector, as well as practical aspects of project planning and implementation. Here on the screen, you can see the selection of 350 projects being at early stage and implemented right now in Europe, the Middle East, and the US. By the early stage and commercial projects, we mean the projects aimed at application of hydrogen and carbon capture technologies at industrial scale, with front-end engineering and design as the cutting point for the early development stage phase of the project. So here you can see that Europe is leading the energy transition, the decarbonization move with roughly 50% of the projects being implemented in the northwest part of Europe. Those projects are more or less equally focused on application of hydrogen and carbon capture technologies. And looking specifically at metallurgy sector, we can see that roughly 14% of those early stage commercial projects are either initiated or implemented in partnership with metals and mining companies. You can, in regard to specific technology, hydrogen and carbon capture, you can see that a sizable part of the projects are focused on different applications of green hydrogen, which provides an opportunity to virtually fully decarbonize the industry. And at the same time, carbon capture, utilization and storage is an option today which allows CO2 reduction while running the business almost as is. And at the same time, this enables creation of new products for industrial sector and other industries. Under the pressure of multiple factors already discussed today, being the shifting consumer demand, tightening carbon emissions regulations, as well as shifting investor focus towards sustainable investments, the industry today finds itself in quite a difficult position, trying to find a balance between running conventional business and at the same time having a possibility for long-term activities. The immediate shift towards zero carbon steel production is next to impossible. So the most viable way is a multi-stage approach, a multi-stage transition from CO2 emissions reduction to full decarbonization. And when evaluating the strategies, the company needs to account a wide range of options and capabilities, among which the most important are site location and availability of infrastructure, including those for CO2 or hydrogen transportation and storage, operating costs of scrap, for example, or electricity, and the overall commercial availability of renewables, such as wind, solar, biomass. Technology feasibility is still an issue, as still we see the limited capacity from suppliers ready to provide performance guarantee for their technology. And of course, regulatory environment and state support are among the key factors. Some of the possible steps, like, for example, efficiency programs for blast furnace are already available and are commercially and economically viable, but the others are still not economically viable. And the key question in this regard is who is going to pay for that? And planning the project, planning the decarbonization pathway, one should thoroughly assess the market demand, the customer willingness to pay for greener products, as well as funding availability, and the investors' willingness to risk. All this economic and technological uncertainty brings, leads to the complex project structure. Куда-нибудь сбоку. My apologies, it's a rocking day today. I was pretty sure it's off. Sorry. The project funding, which is still an issue, requires involvement of a consortium of project partners and a pool of funding organizations. And at the project execution stage, one should be really ready for the flexible project approach, as different project phases may require different pool of partners and different pool of funding organizations. The competition on project funding is really very, very fierce. And when applying for the project funding, your project is going to be filtered by the funding organization through a sophisticated scoring system. And each point at this scoring will weight differently, of course, depending on project specifics and a specific focus of the funding organization. But here on the screen, you see a selection of key criteria applied by funding organizations when assessing the project and when making the decision to finance it. Among the key criteria, based on our and our clients' experience, we would name project maturity, which includes business model, financial and legal structure, and project schedule. And in the majority of cases, you will be asked for the completed feasibility study, either run by the reputable institution, reputable firm, or at least verified by a reputable firm. Of course, compliance with international regulations and policies is one of the important points, as well as investment sustainability score, which is quite often required to be proved by the third party. Degree of innovation and technology readiness level is also in focus, and among the key things you need to prove is your confidence to leverage the full funding required for the project. In other words, every funding organization making the decision to provide you with the requested 40, 50, 60, or however % of funding needs to be sure that you can secure the rest of funding and make your project happen. In the majority of cases, we observe you can be also asked for the positive financial audit run by a reputable firm like someone from Big Four, for example, and a lot of funding organizations are focused also on project scalability. Looking specifically at selected economic indicators usually asked by the financial institutions, you can see some normally applied, like the project NPV and payback period, but at the same time, you can be asked for the NPV as well as CO2 avoidance assessment and abatement cost, not only for your core technology, but also for the alternative technologies, both low carbon and carbon intensive. In other words, the funding institutions quite often want to see that the decarbonization way chosen for you is the best one fitting the industrial needs. All these should be kept in mind when applying for funding. As I said, the competition is fierce, and still it is doable when properly prepared. Talking about the overall business case development and making your project happen, really a lot of points, a lot of different aspects should be taken into account and should be considered. The selection of points you see here on the screen is not unique. I mean, none of those points is unique or unknown. They all are well known, and the art is to keep them all together when managing your project. Because the investment planning today is going under the market uncertainty and lack of habitual benchmarking of best practices, which means that quite often you will need to involve experienced partners able to provide you with the market intelligence and with the proper economic modeling. The investment scenario, given the complexity of the project and given the consortium of partners needed to make the project happen, the investment scenario is to account complex requirements of different partners and different financial institutions, which is quite challenging as well. Technology concept is to account not only core technology, but also related technologies and infrastructure needs, which sounds obvious, of course, but quite often we see those missing points in the business models of our clients and partners.
Oksana, please, 2-3 minutes.
Yes,
Oh,
this
thank
is
you.
the last,
Oh,
the last
okay,
slide,
thank you.
actually.
Thank you, Oksana.
Yes. In regard of the project funding, the key recommendation is to monitor funding programs and calls on a regular basis, since they all are open for limited amount of time, which means that your project model needs to be ready in advance. And of course, in regard of project funding, we strongly recommend to apply financial engineering to secure the full coverage of the project financing, as it was already discussed. At the project execution stage, among from obvious things such as ensuring readiness and accessibility of the infrastructure, provision of permitting, and the rest of things, we strongly recommend to thoroughly develop your procurement strategy to account sufficient timing for equipment manufacturing and delivery. Just to give a short example from our experience, electrolyzer equipment, if ordered and contracted today, can take up to 2 years to be manufactured and delivered. And in this case, of course, you could opt for a wait-and-see approach, waiting while the equipment is getting cheaper, which is the obvious trend in the market today. But at the same time, you are at risk of finding yourself in a long queue waiting for the equipment to be delivered. So this is also should be taken into account. One more factor, the last but not the least, is the project management to account cognitive aspects of multicultural undertaking of your decarbonization project. This factor is quite often underestimated, but still today this decarbonization project is an international endeavor, and you can easily imagine, for example, Poland as a project host, Indians as the owner of industrial facilities, Germans or Austrians as technology provider, and for example, British as project management team.
Or Italian who making from CO2 Coca-Cola.
Yeah, exactly, exactly. Which means that you should account sufficient time to align cognitive maps, understanding of project schemes, and aligning and bridging different business practices and approaches. The key suggestion from our side is that a flexible approach is the king, readiness to continuous adjustment is the king. To make your decarbonization happen, you have to start pilots as soon as possible, negotiate partnerships as soon as possible, and consider sector coupling, which was already mentioned by Alessandro today, to enjoy the synergies of sector coupling, securing funding, and proper execution of the project. That is all from my side, unfortunately. I could talk for a long, but I need to stop. And you're welcome with your questions during the coffee break or afterwards.
Okay,
thank you for attention.
Amazing speech, Oksana. Thank you. Oops. Okay. It was really brilliant. Please, we have not so many time. Our Q&A session also at the end. But when somebody want to ask something from our speaker right now, please raise your hand. Do we have? Okay, we have question. 1, 2, please.
Thank you all for nice presentations. My name is GJ Gravemaker. I work for Fair Expo. I have a question. We talk about decarbonization, and that has to do with the CO2 for the steel. But in the meantime, we produce more steel. So what are the companies, Danieli, Primetals, Paul Wood doing to lower that? Because they still invest, I think, also in blast furnaces. So are there plans to reduce investment in blast furnaces to provide this technology to customers?
It's, I think, a question for our technology suppliers, please. No, you need nothing to do.
Does it work?
Yeah, it works.
Okay. Okay. Well, I think it's quite clear that in Europe, for sure, there will be not built too many blast furnaces in the next time. And what we are seeing already, I mean, of course, the producers have to look very far ahead. Yeah? When they have a blast furnace today, they know more or less in how many years the traveling of the blast furnace would be over, and they would have to make a repair of the furnace. As I said before, normally the producers know that in 8 or 10 years a repair of the furnace would be necessary, and these companies, at least in Europe, they are already taking the challenge. They know that in 8 years or 10 years in Germany, they will not make a new repair of an existing blast furnace. So these companies are starting the projects today in order to have a DRI plant ready to substitute in 8 years when the blast furnace lifetime is ended, to be substituted. That's what's going on in Europe. This is reality. This is nothing what we are dreaming about, it's reality.
Thank you, Norbert. We have seen one more question.
Thank you very much. I'm Dmitry Zotov from Metinvest, Azovstal, Iron and Steel Work. And my question is addressed to Alessandra and to Norbert. Could you please tell us what first steps would you recommend for steel producers, such as Azovstal, Ilyich, Iron and Steel Works, Zaporozhye, which have this traditional production chain with blast furnace and basic oxygen BOF converter? What would be the first steps for us to start this decarbonization right now? Because we do not have ability to demolish blast furnaces, and we will not do it for sure for the next 20, 30 years.
Okay, please, Alessandra.
And electric arc furnaces for us are also not the best solution right now, because we have our own steel melting furnaces.
First Alessandro, and then, okay.
As I mentioned in my presentation, normally in such a case you have to go for the low-hanging fruits. Yeah? There are technologies available where you can reduce stepwise. We are talking 5, 10, 15, 20, up to, I don't know, 30, 40%. You can reduce CO2 emission already with relatively low capex. Yeah? This you can go for. The point is here, of course, this needs a detailed examination on site about the actual status over there, but we are doing this frequently with many clients, that we are studying what's the situation on site, and then we make a study and make suggestions what can be done, considering, of course, that the present process route stays as it is, and still with that and with low capex to make first reductions of CO2 emissions.
Thank you. Alessandro, please.
Let me add that among those technologies, of course, you can study the possibility to charge HBI, for example, as raw material to the blast furnace, because HBI is already metallized, will increase the production, but not increase the CO2 emissions per ton of hot metal produced. Then you can optimize, for example, the amount of coke, because also coke making is emitting CO2. So you can reduce to minimum the coke and introduce alternative fuels like natural gas, for example, that contains 1 atom of carbon and 4 atoms of hydrogen. So you will increase the water and decrease the CO2 at the top of the blast furnace. And you can consider also increase the amount of scrap that you can use in the downstream, not only increasing the scrap as a coolant in the BOF, but you can think of melting the scrap to use this scrap melted maybe with some carbon added together with the hot metal from the blast furnace in the BOF. So there are several steps that can be made, and I think that all our companies could be very happy to help you and make a study about that.
Thank you. We are out of our time. Sorry. I hoped that we will have 20 minutes for Q&A session, but I saw before our event we networking, and now in coffee break, please, we can ask all questions. Please use this unique chance to speak with such expertise, with such people. Thank you very much for this session. It was great.
Out of time, so please sit down. Дорогие гости, мы начинаем нашу вторую сессию. Пожалуйста, присаживайтесь. Мы не так немножко выбились из графика. Прошу вас. Начинаем нашу вторую сессию. We started our second session. Please, on the floor, our chief analyst of GMK Center, Andrei Tarasenko. He will be moderator and speaker of this session. Please, Andrei.
Ladies and gentlemen, we are pleased to welcome you on our second session, dedicated to perspective decarbonization technologies. My name is Andrei Tarasenko. I am a chief analyst of GMK Center, and I will act as moderator during nearest 1.5 hours. We will talk about innovative breakthrough technologies that provide steel industry with carbon neutrality. And you know there is a great uncertainty concerning the terms when these technologies became commercially available, what is the required amount of capex, what is the impact on cost, and eventually what consequences for global and for Ukrainian steel industry. To understand these issues and try to imagine how steel industry in the future will look like, we invited two of our guests and speakers, representatives of European research organizations that are deeply involved in all major R&D projects in this field. So please welcome Mr. Jaap Wente from TNO Netherlands. He joined us online, and Professor Johannes Schenk from K1 Med, Austria. So please, Johannes, take your seat. So let me introduce our speakers. Mr. Jaap Wente holds the position of Roadmap Manager towards a CO2 neutral industry in TNO. TNO is a scientific institution focused on energy efficiency, CO2 capture, and electrification. TNO was involved in a number of R&D projects such as Stepwise, FreeSME, C4U, and others. Today, Mr. Jaap will tell us about technologies of carbon capture, storage, and utilization. Now I'm pleased to introduce Professor Johannes Schenk. He's the Chief Scientific Officer of K1 Med. Johannes leads research in areas of energy efficiency, circular economy, and climate-neutral metals production. K1 Med is an international center of expertise for ferrous and non-ferrous metallurgy. The company is focused on the development of decarbonization technologies and was involved in projects such as SUSTEEL, H2 Future, I3 Upgrade, Comet, and others. Mr. Johannes today will tell us about hydrogen-based technologies for steel industry. But I would like to start our session from the short presentation of our latest study that focused on challenges that decarbonization creates for steel industry. You could get this report for free in the hall on the first floor, or if you are online, so please you could download it from our website some later. And the last thing I would like to say before we start is that our three presentations will be followed by a Q&A session. So please, we have unique guests and you have unique opportunity to ask the questions. So please, if you are online, so please find the panel for the questions in the Zoom. Or if you are offline, so please raise your hand, introduce yourself, and don't hesitate to ask the question. So that's all organizational remarks, and we could start our presentation. So please. You know that best available practices could reduce carbon emissions by 20% or by 30%, and it's not enough to meet Paris Agreement goals. So that's why innovative and breakthrough technologies are needed for steel industry. But you know that currently these technologies are only on R&D stage. Steel industry works on the four main directions to achieve carbon neutrality. First of all, it's hydrogen-based technologies, technologies of carbon capture, storage, and utilization, or CCUS, smelting reduction, and iron electrolysis. My colleagues, Johannes and Jaap, could tell you about these projects in details, but only thing I would like to draw your attention is that most of these projects are corporate-based and closed for other participants. Initiators of these projects are mainly steel companies and predominantly European steel companies. So it's an interesting question for today's discussion. Could be there some difficulties in the process of technology transfer, especially for developing countries? According to estimations of different consulting companies, 2030 seems like a turning year when key decarbonization technologies became commercially available. Engineering companies have already offered hydrogen-based solutions to produce DRI, but you know that widespread use of hydrogen is limited by the problem of its unavailability and high prices. So steel sector is ready for new technologies, but energy sector is not. CCUS technologies are also at pilot stage. You know there is a great issue with storage capacities. So that's why main efforts of R&D projects in this field aimed on the development of cost-effective ways of carbon utilization. Smelting reduction is interesting because it requires reduced capex and relatively low OPEX. But we need to say that the maximum effect on emission reductions, this technology will have only in combination with CCUS. So performance of smelting reduction highly depends from development of CCUS technologies. There are also pilot plants, but they haven't connected to storage yet. Iron electrolysis is potentially the most effective technology, but it's on the early stage of development, so it's too early to discuss it. Most of global steelmaking companies announced their plans to achieve carbon neutrality on 2050. For European companies, it's a year of European Green Deal goal. But since the introduction of CBAM, emissions volume became a factor of competitiveness. So these plans of European companies make pressure on companies from other regions, such as Asia, US, or even Russia. It's a pressure to synchronize decarbonization targets. So 2050 is like a kind of benchmark for declaration of carbon neutrality. But International Energy Agency believes that the global steel industry could reach net zero emissions only in 2070. But during 2050 till 2070, steel industry landscape will change dramatically. First of all, the scrap-based EAF steelmaking could reach 50% in global steel production compared to 30% for today. About a quarter of steel globally could be produced from DRI, it's both from hydrogen-based and with CCUS facilities. Smelting reduction in combination with CCUS also could be one of the main production routes, with the total share of 15% in global steel production. But share of traditional BF-board facilities will decrease to almost zero to 2070. So we see that new technologies will become dominant in the future. And also these technologies bring a lot of challenges for steel companies that will pursue the steel industry in nearest decades. First of all, it's challenges connected with capex, with costs, and with business transformation. The first point may be the most known, that the new technologies are up to 80% cost expensive, BF-board route. So traditionally, technology changes run in evolutionary way when more cost-effective and more productive technologies replace less efficient ones. But today, I guess it's the first time in history when technology changes dictated by the state. So now we see that all new technologies mean higher costs. So it's about all green technologies. And consumers will be paid for all of this. So customers should be ready to accept up to 80% higher prices. The second point is that since scrap-based and DRI-based electric arc steel making became a main production route, so electricity prices will play the key role in competitiveness of steel producers. For example, the share of energy in cost structure of hydrogen-based DRI amounts to 20% and could reach 35% depending on electricity prices. And it's a very important point because electricity market is very fragmented with high difference in prices, even inside European Union. So the level of development of energy generation sector will define the competitiveness of new green industries. So not only steel industry, but all green industries. So cheap electricity will promote them, and expensive electricity so could destroy it. New technologies, of course, mean new construction of new facilities, and of course it's a huge capex. Systematization of publicly available information gave us a benchmark of $1,000 of capex per ton of steelmaking capacity. So for Ukraine, it could mean up to $25 billion of capex to achieve net zero emissions of steel sector. In all regions, financing of decarbonization is a subject of state involvement. And inequality, inabilities of different countries to stimulate the decarbonization process could create some risks for steel businesses. So state environmental policy also becomes a factor of competitiveness. Also, we need to say that the business of steel companies in the future will differ from what it is today. First of all, a number of facilities to be stopped, like coal mines, coke production, sinter production, as well as blast furnaces. But there are conditions for a new business integration, for example, with energy sector. To mitigate the risk with hydrogen unavailability and electricity prices, a number of steel companies that run hydrogen decarbonization projects also realize projects in the field of hydrogen generation and clean energy generation, or have partnerships with energy companies. The second point is forestry. It's maybe unusual, but there are successful cases. Because trees capture CO2, and it could be quite a huge volume that companies could deduct from their direct emissions. So managing forests also could help steel companies to achieve carbon neutrality. And the third one is that steel companies could produce a number of chemical products as a result of CCUS. For example, it could be fertilizers, synthetic fuel, methanol, plastics, and other. So it's new markets, new customers, and so on. But the main consequence of business transformation for steel companies is decreasing number of staff. You know that scrap-based electric arc steel making needs 5.5 times less personnel than BF-BOF production. So if we imagine that BF-BOF facilities in Ukraine could be replaced by scrap-based electric arc steel making, it could mean more than 60,000 jobs cut. And it's a great challenge for steel companies that should respond in their ESG activity. And also it's a point of state involvement and involvement of local authorities. So when someone says that decarbonization could change everything, so that's true. And we try to explore the main challenges and main consequences in our report, and we hope it could be useful for you. Thank you very much for your attention. And now I would like to invite Mr. Jaap Wente. Dear Jaap, we are looking forward for your presentation, so please, Jaap. Hello, Jaap.
Hi. Good morning, all.
Hello. Please, you could start.
Good morning, everybody. It's my great pleasure to participate in this great event. Sadly, I'm not around, but I hope the next time I will be, and that the whole situation on health and travel restrictions is then something of the past. What I would like to talk to you about is basically relatively conventional steel making on the blast furnace and the basic oxygen furnace route, and how you can work on that and use industrial symbiosis and CO2 storage to reduce the CO2 emissions overall. So what do we think then about the CO2 sources that you can think of if you're talking about industrial symbiosis and CO2 utilization? You can think, of course, of all kinds of emissions, and I put here some like industrial emissions, biomass gasifications, of course, also very important to carbon feedstock biofuel production, where there is always an excess in carbon, but also direct air capture you can use. And what can you make then from that carbon is all kind of value added chemicals, you know, from urea as a fertilizer, as already been mentioned before, but also methanol. And methanol is, of course, a very important chemical that is, you know, can be considered as a liquid syngas. You can use as a fuel. A more advanced one is dimethyl ether. And if we look then at what is CO2 use, CO2 utilization, it's basically industrial symbiosis. What you have to do is you have to combine various markets and various technologies from different sources coming. So what I will be focusing on today is industrial emissions and how we can transform that into urea and methanol. And as said, we will focus on steel industry and especially the BF-BOF route. The first project I would like to talk about, the first effort that we did was using blast furnace gas and transform that into methanol as a marine fuel. We have been working on this in recent years, and we have demonstrated that you can actually make methanol. We produce in total 23 cubic meters of methanol, and use that in the Stena Germanica, a ferry line operated by Stena. And as you can see, we work here in a large consortium. I have depicted here a view, Swerim, which is basically located in the north of Sweden next to the SSAB steel plant. There's a location of we do our research, our demonstration work. We work together with CRI from Iceland, and we work with Stena as a shipping company. What we also, what I will pass some more work on is how we are progressing now, and that's basically valorizing basic oxygen furnace gas into ammonia and urea. And the whole thought behind that is that these gases contain energy, and you want to convert the energy in those gases into something valuable. And normally it's being done is be converted into electricity and heat. But we are working towards value-added chemicals to increase the profitability of the whole process. So if we look at the iron steel and in connection with ammonia or urea within Europe, you see there are massive economics impacts. There are huge environmental impacts as well, you know, and surprisingly enough, per ton of product, they have similar CO2 emissions. They are widespread in Europe, and both are quite strongly imported as well. You know, like for ammonia, for instance, 60% is only produced locally. And well, I think the whole impact we already been discussed it. And it's also important how to see how that continues in the future, but also how to maintain it, because the demand will be here. So if we step up, move into a little bit more technological approach, basically, the key technology in here is CWEX technology that treats the BOF gas. And basically what it does, in one step, it converts your feed gas, so your BOF gas, into a hydrogen and nitrogen stream and into CO2. So the CO is converted into CO2, and at the same time, you produce hydrogen. We moved that to the ammonia synthesis unit, the hydrogen and nitrogen, and an electrolyzer to add some hydrogen when needed, depending on the exact composition of your base oxygen furnace gas. Of course, the CO2 has to be tuned, and then if you have synthesized ammonia and you have your purified, tuned CO2, you can go to urea synthesis and have your valuable product. At the same time, you create storage-ready CO2, and I will show later on that storage-ready CO2 becomes available free of costs. So the key technology in here is, as said, the CWEX technology, our sorption enhanced water gas shift. And for that, we built a reactor in Sweden of the size of about 60 centimeters in diameter and 10 meters tall to do the first experiments. But what is that? What is that kind of technology? Well, it's a sorption enhanced water gas shift. And in there, we basically convert CO together with the add of steam into CO2 and hydrogen. And you do that then in a pressure swing manner. So you feed it, you let the CO2 absorb at the sorbent material and until that becomes saturated. At the start, you get then the product of hydrogen nitrogen coming out of your system. And when the sorbent is full, you go into a rinse step and you do pressure equalizations and you do the regeneration. And you use steam for that. And this technology is unique as it uses a very limited amount of energy, a low steam consumption, and it is much more efficient than amine-based systems. You can apply this approach in various markets. And as said, we have demonstrated this at TRL 6 on real furnace gas in the Stepwise Horizon 2020 project and also in the FRESME that I mentioned before. And in total, we have been operating this now for about 9 months. When we go to ammonia, I will look at how the economics play out. And here we compare in blue the reference case, so that's the natural gas-based ammonia production, and I compare that with the price that we come up with. And if you look at the thick blue line and the thick red line, those are the central values that we estimated, and you see that even it's lower our estimates than conventional synthesis. But there's of course some error margins around it. Local situations are very important in that. But the bottom line is the urea can pay for the capture technology, and you get the storage ready CO2 as site product for free. So how does it then in a life cycle analysis? What kind of advantages does it give it to you? The reference case on the left-hand side, that's just common practice as we do now. So you have the gray area, which is basically the electricity production from BOF, and the orange, that is the gas processing and synthesis from the ammonia part. If we now go to our approach, there is the light blue, which is the excess of CO2 that's being vented in this first scenario, and the dark blue is the electricity replacement that has to be done because we still have to make the electricity, and we assume it's electricity as it is in the Dutch grid system at the moment. In orange, you see the gas processing as well. So you see if you just implement it, you get a reduction of about 13%. However, if you go and also store the CO2 that becomes free of charge available, and you have the storage nearby, then you can reduce it to 70%. And the remaining CO2 footprint is basically electricity, because the dark blue on the right-hand side you see is electricity replacement. You can reduce that. And also CO2 transport and storage is also very much electricity based. So even if you can reduce that, then you see that you can lower your CO2 emissions by about 90%. So this is, we have been working that out on paper quite extensively, as you saw, and now we are in the phase of demonstrating this in the real life. So again, we're going to Sweden, in the north of Sweden. We go and expand our current installations to a multi-column installation. And this is a big demonstration that we're going to use, where we're going to produce about 5 tons of ammonia per day, and we're going to operate it for 4 or 5 months. So in total, 3 campaigns we are going to do, and that will lead to a TRL 7 gas treatment demonstration. And we're really going to make ammonia. So again, we're going to demonstrate that you can make your valuable components from still off gases. So coming towards the end, the bottom line is cost-effective CO2 emissions reduction are possible, and the CWEX technology is key on that. And to answer one of the comments before, we are the technology owners, and we are happy to license that to firms and especially OEMs, so we can become available worldwide. Luckily, we're not doing that on our own. We have a wide array of companies and organizations around it. We work together very closely with all kinds of steel companies. In the left top hand, in the left bottom, you see all kinds of supply companies and end users, and you see also OEMs on the right bottom, and all kinds of universities and other knowledge institutes. So we work in a whole ecosystem of knowledge and innovation together. So a big thank you for them. But we cannot do that without funding, and we have been very successful in recent years in raising funds for our approaches in Horizon 2020 projects. And here you see, I mentioned 4 projects that are that have been running in recent years, or that they are still running. And of course, we're looking forward, because we are ready for 100 kiloton per year of CO2 capture facility, and we are very much inviting parties to join us on that excursion, and we look very much forward to doing that and to make an impact. So with that, I come to the end of my presentation. I thank you all for the attention, and I look forward to hearing your questions, and of course to meet you in live, hopefully next year, for instance, at the next forum. Thank you all.
And I hope we could discuss it in more details during the Q&A session. So please stay online for the Q&A.
I will. Thank you.
Thank you. Thank you very much. And now I would like to pass the word to Professor Johannes Schenk. Johannes, please, it's your 15 minutes.
Thank you very much. Ladies and gentlemen, welcome to my speech. It's an honor for me to be invited to this forum and to give you my speech about the future steelmaking technologies and how we in Europe try to meet the climate target by CO2 lean steelmaking. Yeah, about climate change. We have spoken about climate change already several times during this forum. It is evident that we have a climate change, that we have a change in the temperature. This first slide shows you a temporary recording from Vienna since 1775 till the year 2019. This shows you, each stripe shows you the average temperature of the year, and there is a comparison to the average annual temperature in the period of 1971 to 2000, and blue means colder, and red means hotter, and you can see dramatically what happens in the last 20 years. You have a lot of red stripes. We can see as evidence of this temperature measurement that we have an impact, obviously, or with this higher CO2 content in the atmosphere on the temperature. Yeah, we have to do something. Yeah, we have already agreed on the Paris Agreement 2015 that we have a clear climate target. We would like to meet the temperature increase by 2 degrees in comparison to the temperature level before industrialization. And there are also action sets from the political side. This is the European Green Deal in 2019. This defines that Europe has to be transformed CO2 neutral, no greenhouse gas emission until 2015. And if I look at now our own company, Austrian government, have launched a program last year, 100% renewable energy for the electric energy production in 2030, and climate neutrality already 2040. And this means, of course, for the steel industry, we have to act, not react. I say was act, and we have to do something. This is a summary of what we are doing in Europe about CO2 mitigation. Mr. Martinez and Mr. Petermeier already introduced the part of that what is going on. This is process integration. That means all the activities we are talking about to improve existing technology. How can we reduce the CO2 emission, including carbon capture and storage, also carbon utilization. We heard before about that. What can we do to produce chemicals out of the CO, carbon monoxide and CO and carbon dioxide from gases from the steel industry. And I will now keep my focus on hydrogen, using hydrogen, in particular on technologies which are not now available industrial scale, which has a technical readiness level below 7, 8. End of place. Also, there are activities about using directly electric energy. And important topic for me is the circular economy. This will definitely be a very important topic for meeting the CO2 targets, especially in the next 10 years, 15 years. That means in recover from residues, increasing the scrap rate. This will be the topic. Yeah, this is maybe also known. What these are the this slide represents the 4 steel routes, which steel making routes, which we have available. This is the integrated route, smelting reduction route, direct reduction route. These are the 3 routes which are based on iron ore for producing crude steel, and then we have the recycling route based on scrap. And if you look at this slide, I have indicated the potentials of hydrogen use in these routes. The integrated route, we can say about 10% of hydrogen can be used to substitute carbon as a fuel. The route which is now available for using hydrogen to a higher extent, up to 100%, is the direct reduction technologies, especially we have heard about Midrex, energy iron. These are technologies which are now available. The problem is not the technology to produce steel with hydrogen. The problem is to have hydrogen. And yeah, this is now comes me to the issue. What are the topics we have to face? Because we as the steel producers, we can do. But what we need is we have a production. We have to produce hydrogen. And there are electrolyzer. We need to produce hydrogen from water electrolysis by renewable energy. It should be CO2 free. That means we need renewable electric power. Hydrogen production from biomass would be an alternative, but I think it's quite limited to consider it for steel industry because there's a quite huge amount of biomass which you need. A further topic already addressed is definitely the storage of hydrogen. This includes gaseous storage, it includes in liquid state storage. There are a lot of research going on, but this is a topic which is not solved now. Especially if we look for the demand of hydrogen for the steel industry, smaller storage available, but if you think about traffic, the storage is solved, but not for the steel industry. And distribution is a further topic. We have to distribute, we have to supply the hydrogen from the production to the steel plants. And we have to deal it, we have to compress it. These are the topics we are focusing on if we speak about hydrogen use in the industrial sector in the size of steel industry. Okay, but I'm representing K1Med, and K1Med is already active in the production of hydrogen. There is one pilot plant as a flagship project from Europe. It's called H2 Future. There's a pilot plant at voestalpine site in Linz. This is a so-called proton exchange membrane electrolyzer, which has 6 megawatt power and is producing 1,200 cubic meter of hydrogen. Partners are Verbund, this is the Austrian electric power supplier, Siemens, Austrian power grid supplier, K1Med, TNO, we heard before, representative from TMO, and voestalpine are the members of this technology. Yeah, The aim is to demonstrate the operation of this PEM electrolyzer in the environment of a steel industry, which should simulate also the different supply from power from the grid. That means typically fluctuating power supply from grid due to renewable energies. And this was quite well demonstrated. They could run stable operation between 1.5 megawatt up to 9 megawatt. And what is very was for me astonishing is the good efficiency what they achieved, more than 80%. It was a target about 80%. They achieved 83% as a stack efficiency. And the purity of the hydrogen is also excellent, as well as of the oxygen. Yeah, this picture already was shown before. I can just was mentioned from the previous session. What are the potentials to reduce the CO2 emission in comparison to the integrated route? First step, natural gas with direct reduction electric arc furnace reduction potential 35 to 40%. And if we go for pure hydrogen with electrolyzer, direct reduction shaft and electric arc furnace, we can achieve 80% or less. Yeah, what are the potentials we have if we use hydrogen? We spoke about the technologies nowadays. You can see here, maybe it's a diagram which metallurgical guys like very much. Will you excuse me for non-metallurgists? It's a combination of two phase diagrams, with the iron-carbon diagram and the iron-oxygen diagram. And it illustrates how we produce nowadays steel. The gray lines represents the integrated route. You start with the iron ore, then you convert the iron ore in a blast furnace to hot metal with a significant amount of carbon, up to 4.5% carbon, and then later you go to the basic oxygen furnace and to remove the carbon and to make out crude steel. It's a two-step process. Yeah. What is available now as an alternative is the blue line. It's that hydrogen-based direct reduction. It is converting the ore to a so-called DRI, direct reduced iron, and this direct reduced iron you then melt in electric arc furnace to steel. This is what is available nowadays. But the future, and this is the way why we use hydrogen, is the way that we can do it in one step. We can go directly from the iron ore to steel in one process step, and we can avoid these two steps which we have now in future. Yeah, and this is a topic we are researching on in this so-called SUSTEEL or sustainable steel. This is a hydrogen plasma sweating reduction technology where we use ultra-fine ore. This is pellet feed, which we reduce in ionized hydrogen. This has the advantage. Ionized hydrogen is a very strong reducing agent, which is much stronger than carbon, and we can do it in one step to produce out of them steel. This is already demonstrated that it's working. This is a breakthrough technology. We have a pilot plant at voestalpine Stahl-Donawitz site. This is a consortium where K1 Med, voestalpine, and also the university in Leoben are involved. We are still in a small scale. The technological readiness level is around 4 to 5. That means we need additional years until to come to maturity, but we think this will be successful. Another technology which already was introduced, Mr. Petermeier, is the HYFOR technology, hydrogen-based fine ore reduction. This is the lead has primetals, but also K1 Med and voestalpine and also the university in Leoben are involved. They demonstrated already that they can produce DRI from fine ore, which is also pellet feed fine ore. This you are avoiding here also the agglomeration step. And they are also running this pilot plant in the voestalpine site in Donawitz. And they are now doing these tests to get the basis for the scale-up, for the next scale-up step. Yeah. What can you expect in the future for introducing hydrogen-based steel making? Hydrogen is my I think it's last, yeah, nearly last. Yeah. This is the challenge of what we think about. This is already, I think, produced before we start with the implementation of a natural gas-based direct reduction, and then we can switch over stepwise to 100% hydrogen. But the alternative will be, maybe this is a vision for the next 15 years, and to install, instead of this integrated route, a one-step process which is based on hydrogen plasma smelting reduction. This is what we think. I will not explain this slide because this was already discussed, all the topics about the future challenges and the opportunities and constraints. This is summarized what the speakers before already mentioned. There are constraints, but also opportunities. We see strong opportunities with hydrogen in steel making. Okay, then this will be my last slide, the transition to 2050, and we think after 2035 we will also be ready with our technologies we are now developing on hydrogen-based steel making, and we will be available for the implementation. Thank you very much for your attention.
Thank you very much, Johannes. So we heard two presentations from representatives of European research organizations that both on the front of energy transition of steel industry. And now, unfortunately, we are out of timing, so I'll ask only one question. How do you think, what breakthrough technologies have bigger chances to be the first widespread way to produce steel with carbon neutrality? And how do you see maybe the phases of transition to green steel? So please, shortly.
Yeah, I believe the direct reduction, the shaft direct reduction technologies which are shaft-based will be the first, because they have already industrial maturity. They can very easy to transfer from natural gas-based to hydrogen-based. The electric arc furnace is available. They will also be quite interesting challenge will be the direct charging, hot charging to electric arc furnace. This combination, and this will will be also in terms of energy advantage of comparison to the blast furnace, because this route is already better in the energy efficiency in comparison to the blast furnace. The only issue is when will they have enough hydrogen available, but we can start with natural gas immediately. This would definitely reduce the CO2 emission drastically.
Jaap, have you something to add?
Yeah, I think this is a quite appropriate remark, but I think the limitations there are is not only availability, so-called local conditions. How is your locality, how is your government, how is the availability of all kinds of energy sources playing, and how is the storage opportunities of CO2 underground possible? So I think I foresee that there will be a wide range of technologies available, a wide range of possibilities available that all lead to a heavily reduced CO2 emissions from the steel industry. Is there one single winner? We will never know. Well, we will know in 30 years, but not in 10 years. I think many routes will be there, and it will take some time to come to the conclusions.
Thank you very much, colleagues. Johannes, Jaap, thank you very much for joining us.
Thank you very much.
My great pleasure. Thank you. Thank you for having me.
Dear colleagues, now we have 10-minute very short coffee break, and starting our very important session with Ukrainian steel producers. Дорогие гости, сейчас очень короткий 10-минутный перерыв на кофе, попить водичку, там пройтись, и мы, значит... Dear guests, please take your seats. Пожалуйста, занимайте места, мы начинаем. Уважаемые господа и дамы, уважаемые коллеги,
Dear ladies and gentlemen, dear colleagues, this is our third session, and this session is where we will gladly hear about the plans and visions of our Ukrainian steelmakers in the first half of the forum, where we're talking about technologies, about the difficulties and possibilities related to decarbonization technology. And now we're going to find out what the Ukrainian companies think about the decarbonization, because we know that the Ukrainian energy companies, metal companies, steel companies are not standing apart, and they want to achieve carbon neutrality, and this has an impact on the Ukrainian metallurgists, and the Ukrainian steelmakers are export oriented, because the EU market is a home market for the Ukrainian steelmakers. To preserve the supplies to the EU market, we need to bring down the carbon footprint, and we need to introduce the CBAM, carbon border adjustment mechanism, that is really a more powerful stimulus to that. And we would like Yuri Rajenkov to take part in this among the panel, Metinvest Holding, Denis Morris as the first deputy CEO of Interpipe, Maxim Minushkin from British Steel, Brad Sold, Ferrerex, and Yuri Afanasyev for joining online. And Yuri Rajenkov, the CEO of Metinvest, is gladly invited together with Denis Morozov, the first deputy CEO of Interpipe, and Maxim Minushkin, investment advisor on CH Steel. Just take any seat you want, you might find comfortable. We have the absolute freedom of choice, and the same pertains to decarbonization. Who chooses a technology will either achieve a success or will be a failure with any of the technology, as the previous speaker said. Briefly about the companies before the beginning of this session. Metinvest Holding is one of the unconventional leaders of mining and steelmaking company. Metinvest had last year a rise in the environmental investments up to 32%, about the amount about $100 million. Lots of ways for key investments, and $500 million will be invested into environmental goals next year. Then pellets, the total investments will be about 300 million. That's for Interpipe. Interpipe also opened in the EAF steel making complex with a low CO2, one of the best performances. Investments about $1 billion as of 2020. The portfolio volume is $100 million. Given the implementation of environmental projects, SCH Steel is the managing company of the mining and production complex, which is the Dnipro Metal Works, the Sukhaya Belka. Over 3 years, they've been running through transformation, and they've invested about 500 million hryvnias, and the company is making mostly stainless pipes. Many countries are the target in environmental modernization, with a total amount of 140 million hryvnias are planned to be completed in this year already. Our session will be opened initially by a presentation from Yuri Rajenkov, but initially we want the operators to play the commercial in honor of the 15th anniversary of the company Metinvest, and together with Interpipe and Ferexport are sponsoring our event. So please, the commercial dedicated to the 15th anniversary. Well, we'll talk about the Metinvest company. Who are we?
Спогади яскравішими. Ті, хто перековує мрії, надії, хто тягне, хто везе і будує майбутнє власними руками. Бо хто, якщо не ми? Метинвест. 15 років робимо українське.
Очень эмоционально.
Very emotional. It was. Thank you very much. And then I would like to invite Mr. Yuri Rajenkov, maybe right from the spot, or maybe from here, from the rostrum. the way you find comfortable. Good afternoon, dear colleagues. Good afternoon, dear guests. It's a pleasure to see very many familiar faces here. I assume that our way, technology of not only environmental technologies, but steel related technologies and the development of the Ukrainian metallurgy are still making, we are walking together down this track. And that was mentioned by our colleagues. I assume this is very important, not only for the country, but also for the industry as a whole. And today's forum, we as Metinvest, we have agreed to maintain it, to support it, to be one of the sponsors, because we really believe that the topic of decarbonization, the ecology, environment is a very important topic today, not only for Ukraine, but also the rest of the world. And this will be for mankind probably the main driving force when it comes to R&D work and new projects for the next decades, couple decades, up until the time we're going to achieve all the targets that all the countries are setting themselves for decarbonization. I will try to make my presentation not too long. Well, first of all, I would like to talk about where Ukraine is from the point of view of environment protection, not actually environment protection, but speaking about emissions to the environment. If we look into the top left chart, we can see that over the last 10 years, Ukraine has brought down its emission of CO2, of any pollutants. We're not talking about CO or CO2, we're talking about pollutants. And there was a reduction, double reduction over the last 10 years, while the investments into the ecology in our country have risen by much. Let's not forget that given the inflation, they remain on a pretty low level. So the most important investments into ecology, we're in for having them. But the most important reduction that we have demonstrated was rather the deindustrialization of the country, deindustrialization, rather than real economic changes. Where is Metinvest in this? That's about 16% in the total amount of pollutant emissions that are going on in Ukraine, while about 40% of the costs of capital investments that the company is investing into the general protection of the environment in our country. Question, why is that important to us? Probably it is demonstrating that unlike the general trend in the country, then that we are just trying to close things down, not industrialized. Metinvest has chosen an investment way that will hopefully help us retain in the long run the strategically important industry, and at the same time be ecologically pure, environmentally friendly, and meet all the standards that exist. That is the reason why this company engaged in that was a pretty long time that we've been doing ESG, that stands for ecology, social investments, and governance, corporate governance. We got a rating several years ago, and that was by Sustainalytics and MSCI. Sustainalytics have even managed to show their progress. But the most important thing about this to be said is that one may brag on the one hand that we came into the, according to Sustainalytics, we're a top 10 company, environmental company in the world. But if you look into the risks that are being evaluated on Metinvest company, of course that is the case with all the other steel makers. That's the bottom two graphs that show that the environment, the ecology, actually is more than 50% of risks related to doing the business here by the company. And of course, this is the company's focus from the point of view of investments, from the point of view of our practices. What are we doing on that account? First of all, it's already now, apart from the investments I've mentioned, I will mention a little bit later, the company has made quite a bit of investments into the environment, but we have a number of areas that we're trying to actively work on. The first one is related to this particular forum, this particular discussion, and this is decarbonization today. Today, we're in the developmental stage, the roadmap on decarbonization of our company. So today, we already have some interesting developments. I'm going to talk about them later. And apart from that, we're hoping to conclude partner agreements with technological companies that will hopefully allow us to implement all these developments into practice and in our spots and our sites. Number two is our transition into the European system of monitoring and accountability on ecology. And it's no secret to anyone that Ukraine's system is different from the EU one, but I'm pretty sure that in the nearest 5 to 7 years, we're going to be able to switch to the European standards, EU standards, because they already have a legislative base, law base for that. And of course, that pertains to the implementation of the world leadership practices on environmental production, green production of steel, green steel and hydrogen steel that many people have been talking about, that Medinvest is studying. All these directions, our further actions apart from what we're doing already now is doing the automation and working on the automation of all of our environmental programs and all our environmental attitudes. Perhaps it was an interesting discussion because we have the CEO of Azovstal, one of the largest plants where they're doing a project on filters, and that's unorganized BOF shop we got, and there's quite an emission from there. That's one of the largest economic projects of Medinvest. So today he came over and says, let's look into who is managing all these plants. So we don't need metallurgists, we don't need mechanics, we don't need engineers. There we need IT guys, because the whole story, especially when it comes to ecology, when it comes to emission, that's all about modern IT equipment for which we need IT man with the knowledge of that particular equipment, versed in that particular equipment. And that's expected to be the people we need to seek, and apart from that, we ourselves need to work in that direction to develop our plant. Now, yet another forum topic is water. Water is a very serious theme in metallurgy because water is used quite widely everywhere in the workflow, around the workflow, and the way we work with water, the way we save our water, the way we keep our water, the way we treat our water after our work, and purified, clean it. Very important. And biodiversity is in yet another theme that is pretty much of a hot potato for Medinvest today. As I promised, in a nutshell, about our ecological investments, if we look on the whole, then over the last decade, since 2011 till today, we have invested into the environment about $2.5 billion in one or another form. 2.4 billion makes our operating expenses from the point of view of our environmental initiatives, but it is even more important to look into the fact that over the last years, we've been growing the share of the investment constituent of our environmental projects. There is a large environmental project that we have completed, and there are some that we have planned for the next several years. And figure-wise, it will be like $1 billion that Metinvest has invested over the last 9 years into the environmental capex. Now, what was done, there's a number of key projects shown here, and the most key ones that I want to mention is the largest one actually was treatment plants at sintering plant, at Ilyich sintering plant. That was actually the most important pollutant of not only all Ukraine, but also that was actually Ilyich was the largest plant and still remains today, one today in Europe. And today I can proudly say already that the sintering plant of Ilyich is 100% correspondence, 100% fit for the European EU requirements for environmental pollution or non-pollution. And we have fixed our treatment plants, and we have erected the new treatment plants of all the blast furnaces of Azovstal. And now we've been working actively on treatment plants in the BOF shop at Azovstal that is adjacent to Ilyich plant. Now, if you look in figures in particular values, if you pay attention to the right chart, because the left one is not quite all right, they changed it. But if you look into the time period into 2011, 51% was minus dust emission. 37% minus 37% was the reduction in. I'm talking about Metinvest only. And that's about the pollutants emission, and 45% down were the water emissions. Now, next 5 years, starting 2021, or actually 4 years, will be pretty intense from the point of view of our environmental initiatives, from the point of view of our environmental projects. And it was already said about $500 million have been planned for the next 4 years of investments into purely environmental projects. While I'm emphasizing this, because many technological projects have an environmental constituent in them, but I'm talking about the projects that are only environmentally directed. Now we have approached the topic of our today's discussion, which is decarbonization. If we compare the Ukrainian metallurgy with steelmaking, with Ukrainian steelmaking, then today we are pretty much behind from the point of view of decarbonization. In Ukraine, 2.3 tons of CO2 per ton of steel is emitted, while in the EU, European practice shows about 1.9 tons of CO2 per ton. We have pretty serious potential with the environment. I'm not talking about the new technologies that we can, and that also pertains to energy saving. That's also the use of the gases, outgoing gases, and heat, the right mix of fuel and gas and all those things, and the right mixtures, the things that exist in the world today that we need to take over and implement in our plans. And Metinvest have been doing actually. Metinvest, if you look on the whole, the Metinvest has a major share of CO2 emission that falls into the production of, falls into mostly production of pig iron, and then it's followed by chemical compounds. Pig iron is mostly the number one production. It's used as a resurfactant for hydrogen, and when it comes to hot metal, we're going to discard, but we want to bring down the CO2 emission. So decarbonization is the most important target of our roadmap, and the black part pertains to production, pertains to steelmaking. Now, what can be done? There's a traditional way that's been mentioned more than once today. That's the way from BF-BOF to pig iron and steel production. Is there an alternative to this? Alternative is the production of iron, DRI iron, hot briquetted iron, HBI, that can later be by EAC steel making made into steel. And that's the very direction that Metinvest has chosen for itself as a method to elaborate on. And on top of that, we've made our first steps in that direction. Now, why I'm talking about this, because since the beginning of this year, we already have full-fledged DRI class pellet that we started to manufacture. We made our first essentially step. We made our first raw material feedstock that could be used for low hydrogen process of steel making. Now, further steps include the building up of a DRI module and the transition to EIC steel making, EF steel making, EF steel making that will be in future related to renewable sources of energy. I think it's no secret that this is where our plant is, and Mariupol. Mariupol has a very high potential of renewable energy sources, and of course, hydrogen metallurgy. DRI iron that Medinvest are trying to pilot that could also utilize hydrogen later when all the technologies have been honed. That's the roadmap of Medinvest that we're intending to move along. And I'm sure that the first steps we have made already on our part, and I'm sure that other partners have also made their steps to achieve those goals. There's also a number of multitude of other initiatives that we're working on today. That's the so-called CCU, CCC, CCS, the capturing and storage technology that will be later used in the same technical processes. Today, we also have ideas on research, and here I would like to repeat it over again that in this year we're talking about our new university, Metinvest Polytechnic, that we opened in Mariupol, and hopefully it will be not only a staff maker, but it will also be a source of research and new R&D center for Ukraine. And this will, of course, allow us to stick to the best world practices and achieve the values that we're setting today. Just in brief, that will be it, probably. Yes, Yuri, thank you very much for your very systemic presentation. It's very important what you ended in, not technologies and investments, but youth, education, and so on and so forth. Such, I just want to add that Mr. Wiesinger opened the forum, and I think that youth and experience should go hand by hand. Because we understand that nothing is possible without the people, and for to make things work, for the colleagues to make things work, we need the best specialists. We need to teach them. We need to give them the right resources, the right experience. I'm sure we're going to have it all. Now let's switch to the next presentation because we will later have possibilities to ask questions and to answer them, and there will be questions to you as well on environmental investments. And now we're going online, and this is the project, the Chief Marketing Officer of Ferrexpo. So please put it on.
Начнется с небольшого презентационного ролика выступления.
My name is Brett Salt. I'm the Chief Marketing Officer of Ferrexpo. It's a great pleasure to be able to speak to you today virtually about decarbonisation of the steel industry and the challenges that it sets for Ukraine and how Ferrexpo plans to respond. Firstly, just a brief introduction to Ferrexpo. We are the third largest global exporter of iron ore pellets, exporting over 12 million tonnes in 2020. And we have maintained a premium listing on the London Stock Exchange for many years, a member of the FTSE 250 and the FTSE for Good. We've also been positioning our business for climate change and the future that that brings. Ferrexpo's high-grade iron ore pellets enable steelmakers the opportunity to reduce their CO2 emissions by up to 40%. And we've started to position and sell direct reduction pellets, which is the main pathway to green steel, with 2 trial cargoes last year and having signed a long-term contract this year. Turning to the next slide, we're very proud of our performance over many years. Safety, which is always first, has been very good for Ferrexpo over a number of years. And in fact, we've maintained metrics in the safety region better than some of the Pilbara producers in Australia. We've continued to grow our business. We increased our production of pellets last year by 7% to over 11 million tonnes, with high-grade pellets representing close to 100% of our total production. We also invested in growth with $206 million spent on capital last year, taking the total investment we've made in our business since IPO to close to $3 billion. In the space of carbon, we've continually reduced our carbon footprint, and last year we reduced our CO2 emissions by 16%. We have been doing that with reliable state infrastructure, both electricity, gas, railways, and ports. We have an established production and logistics chain, which we own. 6 million tonne port at Tisruda. We own 3,600 rail cars, a piece of a rail barging business, and also a transshipping business, which allows us flexibility to load larger vessels and also deliver to customers directly in Europe. Turning to the next slide, we've been consistently delivering growth, and we're well positioned for the recent market strength. Over the years, we've reduced our footprint of lower grade pellets and are now producing 99%, 65% Fe pellets. And we've moved into direct reduction, 67% pellets over the last year. And this year, as I mentioned earlier, we've signed our first long-term contract in the DR space. These pellets are crucial to green steel and the future of the green steel industry. And Ferrexpo is well positioned for that growth. Turning now to steel production, if you think about the methods of making steel, 2 main methods are around the blast furnace, which uses a high amount of coal, which leads to a larger carbon footprint, and the electric arc furnace, which reduces the iron using electricity, therefore no coal and lower carbon footprint. These 2 are bookends for the steel industry in terms of its future and its past. Both have a place in the future, however. If you're looking at the next slide, we can see that lowering emissions really is around reducing the amount of steel that is produced by a blast furnace and moving towards DRI and EAF production processes. Up to a 95% reduction over a blast furnace is possible using hydrogen in an HBI and EAF process. And again, in these processes, it's critical to have pellets, and in particular, direct reduction pellets. And in the next slide, we talk here about where the governments of the world are moving, and the European Union, as well as others around the world, are all moving towards a carbon neutrality declaration, some by 2050, some by 2030, others by 2060. To be in this space requires you to have the right feed. And in the next slide, we talk about Ferrexpo's own journey to carbon neutrality. Clearly, most of our emissions are generated in electricity and in diesel mining. So as we look to a pathway to carbon neutrality, we're focused initially on things that we can control, looking to take the diesel out of the mining fleets, electrify them, looking at different sources of renewable energy for electricity to reduce our carbon footprint and our emissions with it. And of course, in natural gas and pelletizing. And looking at that specifically in the next slide, there's a number of major streams that we have in play for improvement. We're looking to blend some hydrogen into our natural gas for the pelletizers this year. We're obviously producing DR pellets, which we talked about before, reducing our consumption of gas by recuperating heat as we transition to hydrogen in the pelletizers. Clearly using more sustainable carbon-free sources of energy, such as nuclear and hydrogen, away from thermal coal. We've been successful in doing that this year and the last. And as I mentioned earlier, electrifying the haul trucks to remove diesel consumption, in addition to solar farms. And if I can look at that now in a little more detail on the next slide, we have a project which we're launching this month for a 5 megawatt solar farm pilot project, which we hope to scale around the mine in the future to help us to add to our renewable energy footprint, sourced and produced on the mine's lease. In the next slide, we also talk about biofuel. We started off using sunflower husks in 2015 as another source of energy for the pelletizer. And over the course of the last 5 years, we've increased that from 1% to 25%. And we continue to increase the use of sunflower husks in our pelletizing process and reducing thereby our natural gas consumption. So in conclusion, Ferrexpo's volume growth will be driven through modular expansions of existing production facilities. We're going to focus on quality as we always have and move further down into the direct reduction pellet segment, which we think is a long-term future for iron and steel. We're also leveraging green technology for solar power, increasing the use of biofuel, and decarbonising our mining fleet. All of these pieces of the puzzle will add to Ferrexpo's support both of the industry and our growth in the future. Thank you very much.
Thank you. Спасибо большое. Господин Солт показал интересные два примера из циркулярной экономики.
Mr. Salt has demonstrated two interesting examples of circular economy when the industries are interrelated. That one of the trends is not only for steel making or for actually mining and steel making, are thinking about consortia, but they themselves invest into renewable energy sources. So largely speaking, that's one of the global trends available today. And now I would like Denise Morozov to make a presentation. That's the friendliest ecology, friendliest environment from the point of view of ecology company, the most environmentally friendly company in Ukraine. Welcome, Denise. Can you hear me? Good afternoon. Good afternoon, everybody. My name is Denis Morozov, and I'm here representing Interpipe. Thank you very much for this kind of event, for the invitation. That's a very important topic. And we ourselves in the company, we understand the importance of the theme. We understand that today it's a matter of decarbonization, the future of the planet, Earth being our common home, and many R&D works confirm that within the next couple of decades, if the CO2 emission stays like that, maybe the climate of the Earth will be irreversibly changed, while our descendants will have to live in this planet. And that's a very active, very important and intense matter. And our company has always supported it. Now about Interpipe a little bit. The company Interpipe is a Ukrainian industrial company. We have 5 plants, and all of them are located in the Dnipropetrovsk Oblast. We have a full integrated cycle of production from scrap collection to end product. We do steel pipes, and we do railway wheels. We stand third on export on supplies, and maybe in the world in the first place on cheap pipes. We're among the seamless pipes. We're in the top 10 among the manufacturers. We're working with probably 80 countries. It's difficult to find a place where we are not supplying our products. Our client portfolio captures practically all the large companies. You can see for railway, even they're used in London Tube and Delhi, Barcelona. We're also working with Deutsche Bahn and other companies, and also pipes. Plenty of clients all over the world, starting from Ukrainian companies like Ukrgas Dobыча, gas mining company. all the world's companies actually, yeah, and we're represented in all these segments throughout the world. Now my presentation is called EAF steelmaking and its prospects for the future, because as the guys here said, that there are different kinds of steel and different kinds of steel productions, but today EAF steelmaking is something that can meet European standards. Ukraine is an outsider in this kind of steel making. Only 5% of the Ukrainian steel are being made by EAF steelmaking, 95% by other methods. For example, if you sit CO2 per ton of steel, is about 200, 300 kilos per ton, then traditional BOF production, that's 2 tons and more. So the difference is about 8 tenfold difference. So you can see that countries are actually introducing EAF steel making. You can see that EU, that's 2%, the Middle East 34%, 32% Middle East, even 32%, Ukraine only 5%. So much is to be done in Ukraine to develop electric metallurgy, EAF steel making. That's the norms, that's the rates I was talking about. There's steel making, electric steel making, 150 kilos of steel with 2 tons in 2006, according to the Green Packs. Green Deal theme is something that's inevitable for Ukraine. Ukraine will have to be decarbonized one or another way, or the developed countries' markets will be closed for Ukraine, because it's now secret. CBAM is being discussed by Ukraine, by other countries when it comes to supplies of any products into a country. You have to pay a carbon debt, and that will strike a blow on the steel makers. And only CO2 emission reduction will make us highly competitive on these markets. Just to say it again about the outsiders, Ukraine being an outsider. See the countries around it. Belarus, 100%. Poland, a lot of electric steel making. All the countries have already built out their steel melting complexes, so-called, and they go down a CO2 emission reduction. In Ukraine, it's only 5%. There is also a good example in Ukraine when a steel making plant has been built. That's the 5%. That's in the pipe steel that was built in Dnipropetrovsk Oblast. That's the largest investment over the independence years, because we before that we had an open hearth furnaces, Martin harnesses. You see that there was over 2 tons per ton of steel. That was the size of the emission. Now we made $1 billion of investments, and that includes infrastructural projects within this large project. So we reduced it 80 times. We forgot CO, and the gas treatment system built was the highest. All the pollutants are captured, are disposed of. Water is in a closed cycle. There is no emissions of water. The system is totally closed, and that's a modern time clean plant that people keep going on tours to us, and they are surprised how beautiful we are now. When we made a decision to build up a plant, nobody discussed the Green Deal theme. There were some calls from ecologists, but the theme wasn't popular. Nevertheless, when we made our decisions, so we understood where for ecology, and the company understood that, and that's the technology of production. And the project started to started in 2013. That was the first melting, and today we only work on with steel that was made by that technology. What happened? I already talked about CO2 emission reduction tenfold. For example, you can see here on natural gas, there is a reduction eightfold. So we reduced it. Used to be 145 cubic meters per ton of steel, of gas used, and now it's only 18 meter cubic per ton of steel. We only heat up the ladles and nothing else. 2.5 times all the other pollutants were brought down to European norms. On top of that, we were helped by the Italians and we took money for the plant from Europe and they monitored our emissions and a special inspection came over the first years and confirmed that we have emissions lower than European norms and we were issued a certificate that we have actually a purely environmental technology, environmentally friendly. They even showed our water filters, how we clean it and how we recycle the water. And our plant is not far away from town. There are residential areas, and we also wanted to bring the noise down, and we did it substantially, practically no noise. Just to show you an example, in the city of Udina in Venice, 10 kilometers away, there's like a plant looking like a twin of ours. Now the tourists are attended, there is no smoke, not a single cloud over the exhaust stack. All the harmful substances are being captured, so it's attended by the tourists. The same we have excursions, we have tours, we host tours, we share the experience, and we show what electric steel making is. Interpipe now has portfolio for 3 years, $100 million, and that includes all the projects. Also environmental. What's important? So we made a principal decision that any new investments we're going to look at from 2 points of view: the economic sense that give you niche products, extra production, and environmental. If there is no environmental expertise, we don't take these projects. So we got a lot of work to do, and I tell you what, from experience, that always you can find in an environmental cause, you can find some payback just to do the project. You do the project with R&D and you will pay it back and you will have the good effect. Then what comes next, the key problem is waste that you need to waste, that you need to dispose of. And we're going to bring on the CO2 because there is not only in steel making where we use CO2 when it comes to wheels, when it comes to other things, or for example, key projects. There's, for example, a wheel coupling workshop, and the orders come from the U.S. and we're running into more and more requirements. There's a new hydraulic press that also brings the water down, brings the water consumption down. Now, what's the problem of Ukraine today? According to the analysts, 102 billion euros is what Ukraine needs to decarbonize completely. That's a huge amount that you don't know where to take. You take the European practice, they have already took notions, they have funds, they have motivation, stimulus. Ukraine has nothing like that, no stimulus, and unfortunately, no financial stimulus. Because the norm that we had, that we took 1 year ago, theoretically does exist, but now it doesn't work. So Ukraine's goal is grand, which is a CO2 65% reduction, more than double. But we need to find more than 100 billion euros. That's something that we'll have to deal together with on the level of the state, on the level of the industry. The most important key question about metallurgy, about steel making, is feedstock. Scrap being the most important feedstock. That's what they use, and now all the countries of the world understand that every ton of scrap used in the production of steel is not using about 700 kilos of the coal. Apart from creating jobs, you bring down the CO2 emission, and that's important to leave your resource inside the country. So today, unfortunately, Ukraine, nothing like that is happening in Ukraine. Scrap export grew up substantially. They combusted about 65,000 tons of coal. That was one of the projects that turned into CO2. So today, from the point of view decarbonization, there's a source of scrap, and it would be right to operate on this, just to bring by means of this scrap to bring down the CO2 level, and the steel makers will actually support me by wanting to impose restrictions on scrap export. Export should be limited. Thank you very much. Thank you, Mr. Morozov, for your presentation. Very important things you've touched upon. Not so many technologies that are currently existing, and electric steel making were behind it, and your case is the biggest in Ukraine, and you are running into the problems, as you already said, of scrap and electricity, and the other companies do. And it's not only Ukraine. I just remember I read a column, and it said that scrap will be a future strategic feedstock. Nobody believed, so you indicated its connection with the coal. We looked into the SMS company, the scrap to be used in existing technologies. Anyway, everything goes with its amount. I think in future, given the decarbonization and Green Deal, that's scrap that the countries will use. That's the right way to decarbonization. Okay, I won't take the questions from the Q&A session. I would suggest that we give the floor to Maxim Minushkin, who is an advisor to Sage Steel, CEO on investments. You got 15 minutes. Good afternoon, dear colleagues. First of all, I would like to thank the organizers for inviting me over to this important forum. But also, I want to talk about the Dnipro metallurgical plant, and I want to talk about this case on its way to decarbonization. My presentation will talk today about the Dnipro metallurgical plant, and the topic is upgrading of production to make it more environmentally friendly. A little bit of history to the plant. In 1887, the first furnace was introduced at the plant. That's one of the first metallurgical plants in our country. I just want to notice that the plant has always played an important role in the life of the city of Dnipro, and being one of the largest taxpayers and providing jobs to the population. And this year in 2021, we have marked 134 years of production since the establishment of our plant. Despite its pretty good age, this is one of the largest plants in Dnipro, and the management are full of ambitious plans to modernize their production capacities, including minimizing the harmful emissions into the atmosphere, including CO2. Okay, let's take it one by one. For our company, environment is always a priority matter. You can see a number of state programs, oblast and city programs, where the Dnipro metallurgical plant takes an active part. The examples, first one is a comprehensive program for environmental safety and sustainable development of the city of Dnipro 2016-25, the Dnipro Oblast program for higher safety and implementation of sustainable low carbon environment in up to 2025, 16-25, yes. If we talk about the amounts to actually fulfill the commitments, the plant has already invested about 350 million hryvnias, and it's just to say that this amount does not include any overhauls or any other re-equipment, but that's exactly some pinpointed things to bring the reductions down, including CO2. I will take an example or two. For example, if the first one is the renovation of a gas treatment equipment, BOAF workshop, modernization of the treatment system, and then modernization of torch, talking about the coke chemical site, that's changing the cameras, changing the chambers, then some repairs and the final cooling cycle closure, then waterworks in one of the workshops. And the latest example is also water use and measures related to a casting facility in the plant and use of water. So results, what have we done? What have we achieved? If we analyze the period 2016 to 2020, then we can see by much a reduction of emitting into the atmosphere of all the pollutions, and particularly it goes from 8,232 tons to 2,506. That's about 7%. If we talk about CO2, here come the results from slightly over 2 million down to 400,000, and the percentage of reduction was over 70%. Here also the slide shows a number of events, thanks to which one we have managed to achieve these results. That's the redistribution of energy flows in production, that's reduction of fuel consumption for thermal energy. That's the higher efficiency of production, and also a higher percentage of usage of heating equipment. If we talk about the plants, then plants of this plant for the next several years. Now it has an investment program in the amount of more than $400 million. Just to briefly mention what it includes, and the most important components are continuous casting and the pulverized coal technology implementation, a new rolling mill construction. This amount includes also the development of new energy capacious projects. And it's just also said that the Dnipro plant is going down the way of decarbonization, and I'm sure that the plant will achieve all the intended goals. Thank you, Maxim. It's a very surprising thing. It's a very interesting thing that a plant, an industry with such a story, such a history, is still working and getting ready for the future to work in the 21st, 22nd century. So eventually we'll hit its 300th anniversary, I hope. Now, dear colleagues, I suggest that we're going to have an online inclusion, and this is Center Office CEO Yuri Antanasov, and if you're ready, Yuri, please talk about your vision and talk about your cases and decarbonization. Dear colleagues, hello. If you can hear me, yes, we can. Then I'm ready to share my screen, and I will start my presentation. If you can see the screen, can you see the screen? Yes, we can. Run it. Yes, thank you. Good afternoon, and thank you, organizers, for the possibility to imagine our company and our efforts on the way of the decarbonization of the steel industry. Just to say briefly, St. Travis, we're doing seamless stainless pipes from Nickel. I'm in Nickel. Hello from Nickel, and we are an active exporter. 95% of what we're making, we're exporting out of Ukraine to all the main world markets. Our company has end users, clients or customers from different industries, and that those industries include oil mining, oil refining. That's also automotive, like BMW, Volkswagen. There's also giants, oil giants like Shell, Exxon, BP. actively using our products in the production and further processing of coal and the most and different uses. I tell you what, one example today, every third seamless stainless pipe in Germany was made by our company, every third. As to our interest, here's the good news. We're not doing steel. We're not making steel. Therefore, our interest in this, you're going to ask us why we're here. A few points. First of all, they are our clients, they are our customers. The more we move to the world markets, and the more our brand is getting demanded by our clients, the more we feel pressure or influence of our clients on the environmental agenda. And our reaction here is instant. We have a possibility of, without melting the steel, we have the possibility to choose the steel production, but our first choice is Chinese steel. Just to say a couple of words, the main technology of stainless steel making in China is the so-called nickel pig irons, billets from depleted nickel ore that we mostly import from Indonesia. And this is a very cheap, but it's very dirty and it's very high cost production. It's very, very polluted technology from the point of view of CO2 emission into the atmosphere. And it is by much more, by much higher than we can see, for example, when it comes to open hearth furnace. So we're trying not to deal with this kind of steel. In general, we're only buying something that's been tested in in electric that's been made in electric furnaces, electric arc furnaces, and this is our active contribution to the environmental agenda. So this is why there's a movement from the clients. Number two, there's a movement from our own staff. I will talk about it a bit later. So we have all possible grounds to be, if not in the on the front line, but actually an active participant of this movement in Ukraine. Our colleagues have just said, previously said, why this agenda is very important, so important today, why we need to support Ukraine. So, of course, it's very important for every one of us to make his own contribution into this progress. So what does the company do? St. Travis. We decided to cite an example of how we can influence and provide for further CO2 reduction into the atmosphere by using our technology, seamless stainless type, pipes. There are two ways of heat treatment of our pipes. It's important to have a heat treatment. So there could be normal furnaces, gas furnaces, to deal with it in open atmosphere. And here, as you understand, there's the whole spectrum of sintering. I mean, there is the formation of chrome, iron, nickel, and other metals. There is a more modern, more cutting-edge method, environmentally friendly or carbon neutral. That's the heat treatment, where in a medium we use the medium of as atmosphere, a medium of hydrogen, which leads to a lot of effects. So basically, if you're doing environment seriously, the thought was that you will get an effect in the product and in the economy itself. Here's the example of our furnaces. We have two presented here, but we have three actually, and that's light annealing furnace. so-called. That was the most modern back in 2008. So why is that important from the beneficial, not only from the point of view of the environment, but also our production process and our clients? Just a little bit of excursion into these things, technological things. You will see some roughness of the surface, and you can see on the left. You can see there is a normal pipe from a normal furnace. You can see some roughness of the surface, and you can see some internal roughness that really impacts the consumer properties of the end product. On the right, you will have the so-called light annealing. It's not a unique technology for our industry, but it is pretty rarely encountered. And in Europe, beyond Europe and the EU, I said that the client was pleased with our quality, and our guys are working in better conditions, and it's important, and especially good to that the environment gets no negative influence impact from that process. Now, briefly about in dynamics about this particular point, or something that will relate to that particular point. Back in 2007, we supplied our first oven, and there was actually an investment into hydrogen and nitrogen plant. We had bought like 3 furnaces around that time, and the total amount of investments was about 10 million euros. And this year, we are more focused on points related to the environment, which includes sustained boilers, and also, as requested by our staff, we are implementing a system for a divided collection of industrial wastes. It's impossible to do without a larger staff, and we're building up a new complex, a full cyclic and reagent treatment of our acidic runoffs. And in 2021, the total amount of investments on these investments was 4 million euros, not so much compared to the figures demonstrated by our colleagues, but this will make 50% of our common investment in this year. Plans for the nearest years, for the nearest future, is to deviate from the regular annealing and we will need more furnaces and further excess capacities on hydrogen projection. That will require 5 million more euros. I would like to complete my presentation by saying that this is our choice. We may wait to be fined or to be compelled or forced to do those investments, but you can also move ahead in response to go with the times, in response to the times challenges. I don't know if I will say something else, but just to focus on Ukraine steel making is going through a good stage, given our cycle, especially we have all the good possibility to get a good profit. Let's invest in this future profit to be, and steel makers, metal makers will have a professional holiday in the next weekend. I would like to congratulate you on this holiday. Good example, good presentation, supply chains that we're drawing here. There is a production of stable pellets. There's a production of all kinds of steel things, and EAF electricity making, EAF steel making. And there's an example of responsible consumer manufacturer. I worked a lot with logistics by background, by experience. Sustainable supply chain is the most important thing in logistics. That's the matter of stability down all the supply chain. Yuri showed that example excellently. So down this example, you can either believe or not believe in climate change. But if BMW and Mercedes say we're going to buy green steel and green parts, and all our suppliers need to prove that they're proponents of that. So if you want to be a supplier, then you have to actually invest into ecological modernization. Now, dear colleagues, I can keep talking a long time. Now let's switch to Q&A session. Please raise your hands and you'll be approached with microphones. Are there any questions, dear colleagues? No questions, I will ask them. If everyone is so shy. I wonder, I want to ask a question to all the participants here. Either when it comes to a decarbonization process, are there any new possibilities, because we've been talking about technology, or is it only risks, investments, and challenges and problems for metal makers, for steel makers? One sentence from each, please. Always, when it comes to all the risks, there is opportunities. That's a given truth. And when it comes to decarbonization, here is the same story. Now let's take an example of Metinvest and the projects we're doing now. I will take an example. If we didn't think about decarbonization, we would not probably look at some DRI possibilities for electric steel making, because the colleagues have built magnificent metalworks, and now their challenge every month is they struggle with the task of taking metal scrap somewhere. That's a big problem. I myself was fond of the building up the first electro steel making plant in Ukraine, in Donetsk, and I took an active part in that project. And I know all those issues about it. So when we used to look at electric metallurgy as Metinvest, we said that okay, good, we're gonna have an electric steel making. Where do we take this scrap? Yeah, we have decarbonization story. We have high quality pellets, and we have a new idea. And if you look at that from this angle, what does it give us? It appears that when it comes to decarbonization, we can give a second life, second chance to the Ukrainian metallurgy. We can support the old technology and live with it. But the other thing that we want to build a new technology, modern technology that will live 100 more years. So here is the example. There are risks that give new possibilities. Good example, Dennis. I absolutely agree with him. There are possibilities and risks. For example, when it comes to with SPK, when we established it, we learned to make steel, and what is going on. Eventually, we have studied this, and now it's all about the quality. That because what's the decarbonization? That's saving resources. The less gas I use, the less CO2 I discard. So it's always a shorter energy consumption and then decarbonization. It's important for any business should be max efficiency, and it's very important. And any new idea, any new theory, including decarbonization, will have to give you a new additional effect, GRI and other examples. There also will be more possibilities. I'm sure that in 5 years, will be new interesting technologies that will substantially impact the economy of Ukraine. Um, it's no secret that some time ago our plant was had a downtime about 7 months. There was a not very good market situation. And that was a challenge, and we overcame that challenge where we give the plant a second life. So I think that decarbonization is a certain kind of challenge that we're going to overcome. Thank you very much. From Ferexpo, we have Yaros Lavna Blonska. Maybe you can comment on that. What possibilities your company will see in decarbonization? Will it make a transition from DR pellets to DRI completely? Thank you, Stanislav. Now about our plans, I think that my colleague Brad Salt pretty vividly shed light on what we have already done. We are moving to the final goal, and we're gonna increase the production of GR pellets. And Ferexpo is ready for dialogue with companies, with our clients from the EU and not only. And we are ready to look at your uh, proposals. There is a question from Zoom for Yuri Atanas. Yuri, you're with us? Maybe there's a commercial interest here. Do you use Ukrainian or imported steel? What kind of steel you use for your pipes? We buy steel 70%, 75% we buy Ukrainian steel. Ukrainian steel made by Dnipro Spetstal from the city of Zaporozhye. So you're commercially open. Yeah. And that's a BOF. That's electric. For Yuri, my question is your company getting ready for Simbam or and any roadmap to that, any plan? And yes, we are getting ready. We are doing a very active dialogue also with a person from the European Commission, what CBAM should be. Our main message is that whatever system has been introduced, it should be just on both parts of the border. If it's on both parts of the border, then it will be taken well. Everyone will work with them. So here our specialists, together with the representatives of our ministries and the Prime Minister on the European integration, they're part of the work group to produce this system. In our understanding, it will be better to either connect Ukraine to the trading of European emissions or bring it up to any other system and regulatorily one should deal with that. But our main focus is energy saving, is technologies to use to the best extent. The energy that we have to use to the best extent for the product to bring the carbon footprint down to the European practices. Talked about I'm not talking about electric steel making. And the second topic is more long term. That's the projects that were related for the future. That's new DRI plants, new metal making, steel making complexes that will allow us, together with the renewable energy, will make us CO2 neutral, even negative when it comes to steel production. That's what is related to our footprint on the European market. Somebody has a question or two? Then I will use the possibility and ask the question to the speakers. It's a very important thing you raised. That is energy saving. But when we did our research, that everyone has an opportunity to familiarize with, we noticed the growing pace of cooperation, making of platforms for steel workers with renewable energy sources. So the question is for our speakers and participants. Maybe there will be a cooperation of Ukrainian steel companies or steel companies in separate with some energy companies just to build because it's not the matter of what energy you're buying, that's a matter of infrastructure. So if possible, Maxim, Dennis, and Yuri, comment on that, please. I will start. I think that the CH is absolutely open to all the proposals and will look at all the possible options. We will to support and we are interested and we are open. So I think that we might build a full chain. We 10-15% in our production is the electricity. We're discussing, we're looking for options, we're ready for cooperation. We're looking for green energy, green steel, green chain of suppliers. I can say that we already made the first steps in this direction. And as you know that we have a DTAC sister company that's been dealing with renewables and energy and wind, and already today we have a joint project on the use of renewable energy sources, not only in metalworks, metal making, but also in the production of hydrogen. That can today bring it down by much. I mean, the carbon footprint, even traditional metallurgy. So we can see about 20-23% of reduction could be achieved by the use of hydrogen and traditional method. And today we already have this project. Super. Then I conclude to myself that we may count on some kind of cooperation of steel companies in the energy area, because I understand perfectly well that everyone has a need for pure energy. Because that might be decarbonization already today. And the other question is from Zoom, and I would like you to comment. What is the trend on CO2 emissions in metallurgy up until 2030? Upward or downward? Somebody from statistics, somebody from a state cadastre. Does anyone have an understanding? Have an understanding? It's very easy. I think it's 100% downward. From what was said here, because new metallurgy will be oriented towards CO2 emission reduction. So Ukraine's trend will be the same. Energy saving and development of technologies that will bring about an emission reductions. So it's a downward trend, right? Right. I just meant when today we were talking not slogans, we were talking about the particular projects that are being implemented. So I assume that we're going to achieve that kind of success. The Ukraine needs a financial stimuli. You need to think about how to get money. We need programs. We need hundreds of billions of dollars. And that's an important topic. There's a trend. There should be tools. Thank you. Yuri, maybe you want to comment? I can only say agree. I agree. Yes. It's obvious. Given all the factors, the trend will be not only downward, it will be an acceleration. So we need some time to unfold those programs, implement those projects. So I assume we're gonna track that down. And it will be good if GMK shows the statistics in this mode, just to motivate ourselves. Thank you. I wanna talk to Yaroslava. We saw sunflower plus pellets. Can we expect by 100% of the use of renewable sources of energy from Ferrexpo? We are going to this. And there's a new pilot project of solar energy, 5 megawatts in this month. We understand this. We understand how to implement this project. We understand the difficulties. So by all means, this is a only green energy, trends towards the green energy, wind energy, and so on, and hydrogen. Thank you very much, dear colleagues. Now we have a little surprise. Our today's forum is not just a forum, it's not just a platform for decarbonization discussion, but this will be a platform for cooperation. First of all, I have a unique possibility to speak to a lot of foreign experts. And also, I want to say that I would like to invite here Yuri Zhizhenkov, Medinvest, and representatives of Prime Metals for signing of the memorandum for cooperation in the area of decarbonization. I can already see.
Mr. Norbert Peter Meyer, please, Mr. Rezhenkov. Please change the paper. Yeah, thank you. Попозируйте, пожалуйста, пожмите руки. Да, спасибо большое.
Pose, shake hands. Thank you.
Thank you, Mr. Peter Meyer. И сейчас я еще хочу пригласить
Now, I would also like to invite Mr. Humer from Cabinet Research Organization to sign the second memorandum between the Cabinet and Metinvest. That's about starting cooperation in the area of first decarbonization R&D and metallurgy. Please, Harold.
Thank you. Please, and photo. Спасибо большое и thank you very much. И я еще хочу поблагодарить всех наших спикеров.
Just say I appreciate all our speakers and I suggest that you continue. Press has questions at the coffee break. Welcome, please.
Guests, please take your seats. Дорогие гости, прошу вас, проходите. Начинается последняя по порядку, но не по значению сессия. Прошу вас, Александр Федорович, модератор нашего мероприятия четвертой сессии, прошу подходите, приглашайте гостей.
Коллеги, занимайте места.
Dear colleagues, take your seats.
Коллеги, прошу вас, занимайте места.
Dear colleagues, take your seats. Because we got a little change to the session, but they are for the better. We have more speakers than we wanted to. And we counted on. It's by far more interesting than out there. We also need the colleagues from behind the chairs, from behind the tables. Okay, good afternoon, dear participants. It's very important. My name is Alexander Kalinkov, and I'm the leader of Auto Metal Chrome Association. This is an association that joins together that all the mining and steel industries in Ukraine, like an association. It's very important that we've been discussing this topic. And you have all seen during today that there is a trend. In fact, that's a new reality that we're all living by. That's the reality in which all the European countries have lived over the last decade, and our industries have adapted a long time, and it's gathering speed now to remain competitive, to trade in Europe on the global market. We have no other way rather than go down this path. Given the fact that our metal companies and our mining companies have been global a long time, and we are listed, we're a shareholder. So just like Arcelors and so on, our companies have money on the external markets and they sell their products to external markets. They export, so they're global. They've been global a long time, and it's no wonder that this trend of decarbonization or the green development for metallurgy, steelmaking, and for mining companies is a priority. So I hope that we will be the industry that will be the trailblazer for the other industries, given that GMK is one of the areas, one of the industries that makes quite a big contribution. And it's a very good reason that yet another one that will pay a lot of attention to this process. The first part will be how we technically implement decarbonization, and then third part that was initially, and then the third part where I listened to business representatives that talked about the real-time projects that will also take place in future. But most importantly, we need to understand that's a global trend requiring a lot of resource, not only money but also efforts from industries, and it will only take place if Ukraine acts within a certain institutional framework, which concerns regulatory policy, which concerns lawmaking initiatives, bylaws, the establishment of a whole system for allocating money to a project that's related to decarbonization. Some matters and questions were already voiced out. Decarbonization and trade policy on the solution on scraps is quite an issue for our industries, and a full cycle integrated and EAF, steel making, regulation, state regulation, take whatever policy in the state that has to do with environmental issues, decarbonization. So it's extremely important to create a system in Ukraine that will potentially allow our companies to go down this way. And we're in a good position because the European companies went down this way by far earlier than ourselves, and they already have this system. And it's important to understand how this system functions in Europe. given in Europe, it's been changing lately. Today, they need to announce the 55 package by the European Commission. That's a decision by the Commission, and we will see that part of the institutions that were created now are changing, that the process is gathering speed, and it's important to feed this process. Nobody will talk better about that, how in Europe that is built, and we are
our honored guest. And I think he is very well positioned to describe how this institutional framework works in European Union and what is the European Steel Technology Platform, what role it plays in this transformation for European companies, and what Ukrainian companies could benefit from this system or adopt some kind of such system in Ukraine. Thank you very much. Dr. Klaus Peters, can you hear us?
Yes, thank you very much, Alexander, for the kind introduction. I'm very pleased to contribute to this very exciting workshop. And as the other online speakers have said, I would have loved to also travel to Ukraine and to participate in person. Let's hope that soon the situation will improve and that at another occasion it's also possible to meet in person again. And also, I'd like to say thank you for sharing the experience within STEP about this low-carbon steel making with all of you. And it's a good coincidence that STEP started with ultra-low-carbon steel making, the ULCOS project, and now it's about the materialization of the Clean Steel Partnership at European level. All the topic of yours, of your day today. Let's start with STEP, the European Steel Technology Platform. And it's almost 2 decades around now. And a few years before, we decided to give it a legal entity frame, mainly because of compliance reasons. The world became more complex and challenging to bring competitors together for collaborative actions, and therefore in March 2018 we founded as an international non-profit Belgian organization. And it was quite a success, as you can see that by mid of this year the 13 founders more than tripled in regard to the number of members, as shown here on the right side. One member I like to emphasize on, that is Eurofair. And Alexander, you mentioned that it is important to understand the complex system in Europe, in Brussels, about technology, research, innovation, and the supporting or demanding framework from policy and regulation. And that is the role model of STEP and Eurofair, so to speak. So the one element, Eurofair, as the Steel Producers Association, is the main financier of STEP. Having said this, there is no public money in STEP. We are a privately financed platform. Eurofair is dealing with these policy and regulation elements. They are also carrying out trade cases and these elements, but in close collaboration. We are sitting in the same building. And the membership of STEP is quite diverse, going far beyond the steel producers and the associations as in Eurofair. So many of today's speakers are also STEP members, so the RTOs, for instance, or the plant builders, and universities as well as suppliers. And we are also reaching out to customers, so the full value chain comes together. And what do we do within STEP? That is summarized in our mission statement. It's about collaborative European actions, mainly projects on innovation and technology to tackle challenges on European level. And always, of course, we have in mind to stay profitable, so to create and support the sustainable European steel industry. And how do we do this? As STEP, I like to stay within the intended 15 minutes, I cannot go in all the details, but I'm happy to take further questions also by email later on. So it's about being a service provider to the members and create added value. And the core document of STEP is our strategic research agenda, also of course freely downloadable on our website, in which all the various activities are summarized. And so whatever we do within STEP is at least covered and mentioned in our research agenda. And how do we do this? As I said, we are privately organized. If we look in the center, the STEP office is a very small one. So this is just 2.5 man capacity. All the rest of the very impactful activities within STEP is done by the members on a voluntary basis. And this is the organizational chart, very typical for an ASBL, so the General Assembly, a lean board just composed of 4 members. And then I'd like to emphasize the 2 core groups. The steering group dealing with all the platform activities supported by the focus groups. And you can see by the name, the main orientation of these groups, for instance, tackling these low carbon technologies or reaching out to higher levels of circularity, as well as the implementation group, which tackles all elements related to the European Clean Steel Partnership, and in this regard prepares the meeting with the public side of the partnership, which is the so-called partnership board. And I like to emphasize that we have this open and transparent approach within STEP, which I consider as one of the success elements. So any member of STEP is by definition member of the steering group and member of the implementation group, and as such has full access to all our STEP activities and of course all the information. And some examples about these activities the members of STEP contribute to and also benefit from are summarized on this slide. So the one element is STEP, of course, provides information about the ongoing activities and also opportunities for supporting instruments for research and innovation. And many times I can really share with you, we are receiving questions that shows us that the language which is used in Brussels is already a very specific one and not self-explaining. So some additional explanation is very helpful, in particular for the smaller members. And it's not only that we translate what is given, so to speak, STEP is also in the position to contribute to the writing exercise of roadmaps and work programs, which then translate into funding opportunities. We have started a few years ago a very intensive new activity, meaning the so-called thematic workshops. Here you see the list of the titles. And on the right side, the flyers for the digitization, for instance. We even published a booklet, which is available for sale in the Springer Verlag. And very soon we will publish our highlight report for the last year of 2020. And for instance, the hydrogen-based steelmaking workshop was very attractive. So we had even a director from the Commission attending the closing day, making the summary, so to speak. And we gathered more than 140 participants for the 4 Zoom meetings. And going from this platform-specific activities to the Clean Steel Partnership part of STEP. This is summarized in the following slides. So the objective of the Clean Steel Partnership is to develop lean CO2 technologies. So it's about technology development. The delivery in regard to reduce the CO2 emissions, this will be done by follow-up activities from the producers. And the partnership is going beyond many of the past experiences in regard to research funding, because we really want to go to test technologies at large scale and high TRL, so that the remaining step to have an impactful realization and implementation within the steel producers is an easy one and as much as possible de-risked. So therefore, we contribute to this ambition and the commitment from the producers to become ultimately carbon neutral by mid of the century. And being smart means, of course, to do this in a way staying competitive. And there, the framework decided by the policymakers on European level and national level is very important. And the result is that we have there a very inclusive approach, so that within the partnership, various stakeholders and are involved, and they are technology open. And already pre-speakers said we have to consider the specific situation on the various sites across Europe, that not one silver bullet will solve the decarbonization challenge for the European steel industry. And to be very concrete, the partnership is committed to deliver 2 demonstrators for the 50% CO2 reduction in the very coming years, and a little later, 2 demonstrators leading to an 80% CO2 emission reduction level. And some more characteristics of the partnership. So it's a European partnership, meaning it's part of the Horizon Europe innovation program. A typical project size is 10 to 100 million. As of now, we are more focusing on the 10 million, but in order to really deliver our ambition, and we also want to go to higher funding projects. And it's about starting TRL level 6, so it's almost so we are not considering feasibility or lab research. It's all about pilot and demonstration in an industrial environment. The size is 1.4 billion, 50-50. And the unique positioning is that we have 2 public financing legs, so to speak. One is coming from the RFCS program, the Research Fund for Coal and Steel, and the other one from Horizon Europe. And this is at least matched by the private side. We even committed to outpace this by expecting to invest from the private side 1 billion or more. And this is, of course, not the full budget envelope for the needed research, development, innovation activities for the decarbonization. Higher amounts for the research are needed, and we already learned that the numbers for the implementation and the rollout are another category. So there we have to add a couple of zeros. And to look into a little more details in regard to the content, let's see how our strategic research innovation agenda describes the pathway, the transformation of the today's steel producing landscape into this carbon neutral element. And it's to some extent, of course, the repetition of previous speakers. So the one approach is to avoid the use of carbon as a reducing element, by replacing it with hydrogen and electricity. And then there is no CO2 process gas created, and therefore we don't have to deal with any CO2 activities. The second approach is the so-called smart carbon usage, here in blue, with also 2 underlying pillars, which means, yes, we may continue using carbon as a reducing agent, but then we will do it in a smart way, meaning that all the CO2 generated process gases in our steel making facilities will be captured and not emitted. And then there are other two principal options to use it. We have learned already a couple of examples for fuels or for chemicals, or we store it. That's the CCS approach. And embedded into this is, of course, also the further optimization. Process integration is here the key word, meaning combining process steps so that the overall generated carbon dioxide amount is reduced. And the overarching principle is full in focus of as well within the Clean Steel Partnership, which is aiming at higher levels of circularity. Also, when we change some processes, we also need to see how industrial symbiosis, for instance, for the slags can be guaranteed. And in order to allow the collaboration among the competitors, we made the approach to break down these more company-orientated technology pathways into the so-called building blocks. They are listed here in the lower right of the figure. And these are basic elements. And if you combine a couple of them, then you will have the projects and the transformation of a concrete site into a carbon neutral production of high quality steel. And I like to highlight one, which is the building block number 4, the product adjustment. And here we really pay emphasis on that we are working in a brownfield transition approach. It's not that we define on a green field a new way of steel making. No, we have to continue with our today's facilities. We have to continue supplying the customers, and we have to also continue to invent innovative products with appealing characteristics and properties and performances for our customers. And on top of this, we have to master the decarbonization challenge. So we need also adjustments of today's production to test as best as we can the future situation. So to get used for higher amounts of natural gas and hydrogen, for instance. So having said this, these are the areas of intervention where we made the decision in regard to the budget split. So the budget is not split according to the 1.4 billion to the building blocks, but to the areas of intervention, which are listed here. It's the technology pathways and the underlying substrands. And one element is also very important, that many times we say, yes, we also like to use the opportunity to make improvements in regard to digitization. And I welcomed this word from the previous speaker. We cannot do anything without the people. So social innovation is very important. And in order to safeguard that this is more than a lip service, 2% of the budget is dedicated to the enablers. So therefore, they must be fully included. And in regard to the status, the partnership will be documented by one document which has a signature, the Memorandum of Understanding. And just before the break, we could see, and I'm congratulating you to the signing of the Memorandum of Understanding for your decarbonization efforts. We had the plan to sign the memorandum for the partnerships last month, but this was delayed. There were some difficulties, so now it's done by electronic signature by the presidents of STEP and the public side, the Commission. And you can see, so First Alpine is today supporting STEP as president, and Eurofair, of course, also as vice president. And the partnership as such is a new partnership, so it's there's no predecessor to the Clean Steel partnership. And even if the memorandum has not been signed, we expect the signature in any hour, so to speak. It's in full operation. So on this slide, I'm sharing with you today's view in regards to the funding opportunities provided by the Clean Steel Partnership. And again, you see the two legs, so this orange color highlighting the Horizon Europe, and the more green color, the RFCS element. And in particular, I like also to mention that for RFCS to work like this, we needed to implement a modernization package, meaning changing the legal basis of RFCS, allowing to tap into the assets using as a support for our decarbonization transformation. And we can see the high TRLs, and the European contribution is still single digit, and here you can read some elements. And the size is, as expected, something like 100 million per year, 700 million funding in total. And having said this, let's conclude with a summary as the vision. And this is our official statement. Let's be the first climate neutral industry sector in the European by reducing the CO2 emissions. That's very important. We have the means in our hands to reduce the CO2 emissions. We are not relying on compensating measures. And the big difference compared to ULCOS, here's a 2016 chart. Today, we do have so many high TRL or even at implementation stage, industry-driven projects receiving big support, for instance, from the Innovation Fund or important projects for common European interests. And may I conclude with a more personal comment? If we already go to this climate neutral position, then let's please do the one little step more, because one single CO2 molecule can make the difference. Let's be the first climate positive sector. I really think being climate positive is a much more self-selling statement. And we as the steel sector have the chance to be this. We know the technologies. We are not afraid of doing the final steps in regard to the research and development needs. And we have also technologies in hand to be even CO2 negative. And I'm very proud to be able to contribute to this transformation of the steel industry, also changing the image the steel sector has, no longer being rather negative, but now positive, being really a solution provider in Europe.
Thank you very much, Dr. Peters. Your contribution is very valuable for us, because the steel industry in Ukraine is still in the starting position. As a head of Steel and Mining Association in Ukraine, I'm looking forward for further communicating with you, including in person. Also invite you in Ukraine. Please stay with us, because at the end of the panel there will be Q&A session. Сейчас хотел бы дать слово Андрею Глущенко, чтобы он вкратце рассказал.
And now I would like to give the floor to Andrei Gloshenko for him to talk briefly about the instruments for the financing of decarbonization in the EU. I would like to show my little presentation. That's the one from our research, and it will come up, hopefully. Financing of decarbonization is one of the important problems that always come up with our discussion on new technologies, especially when it comes to greenhouse gas reduction, emission reduction, and decarbonization requires lots of investments from the state as well, not only from the industries. And we decided to look from a side how this is being dealt with in the European Union, because the European Union is the absolute leader in the area of decarbonization. And this is what we have found out, and I will try to share it outcomes. First of all, we have found that to finance decarbonization, what is being used is basically the same tools as for stimulation of other activities, which is grants, which is loans, beneficial loans, which is loan guarantees. There might be subsidies to compensate for operating and for capex and opex, and these are instruments are allowed by the World Trade Organization, and they're stimulated by the Organization of Economic Cooperation and Development because they are to achieve environmental goals, just to bring down the greenhouse gas. And in the EU, the state is in fact an investor into the decarbonization area. As far as you can see from the slide, financing of the decarbonization from state is highlighted as almost the amount of 790 billion euros. Thus, you may conclude that the climate policy in this case becomes a factor of competition by having this high-scale support from the state institutions. The European steelmakers are overtaking CO2-wise the other manufacturers are setting a special benchmark on the level of this area on the whole. And since the European policy is so efficient, I suggest that we look at further in detail how each of the tools works. As far as we can see in this slide, the European Union allocates grants. Grants, first of all, on R&D activities, and there are two directions for allocation of grants. There are two most important institutes, which is for Horizon Europe, Recovery and Resilience Facility. Horizon Europe as a program is a known fund for funding research, and in the new version of this fund, we look at a certain budget for financing low carbon metallurgy. And this is a partnership of Pure Steel, and this is carbon low steel production. And there's 350 billion euros that's been allocated, and another 300 million is allocated by the European Coal and Steel Society. And the partnership meaning is that half of this budget of this partnership is allocated from public sources of financing, while the rest of the other half, is funded by the industries, by the plants on their own budgets. And in the framework of this partnership, different developments and technologies are being funded. And it is expected that in this year, all the formalities will be through with. And since the second half of this year, this partnership will gather its speed and will work at full capacity, as Klaus was just talking about. And it's expected that in the framework of this partnership, they will finance projects with a budget of 10 to 100 billion euros. The second way of getting a grant is recovery and facilities. That's an EU thing to overcome the COVID consequences. It's expected that the green and digital economy transformation will be funded, so the money will go from the grants, which we can see in this slide, and also some beneficial discounted loans. And you will see in the next slide that through Recovery and Resilience Facility, the plants can get up to 360 billion euros of loans. And also the EU looks at loan guarantees that are to relieve the industries in their way of getting a loan from international financial institutions like the European Investment Bank and the EBRD. And according to the European Commission, the use of Invest EU will allow one up to 40 more billion investments in decarbonization, because that's part of the European Green Deal. If we look at the highlighted volumes, and if you remember the estimates about how much the European metallurgy is for the decarbonization, this is what it looks like. According to the estimates, 140 billion euros of investments are necessary. And this is actually looking at the amounts that they are able to raise from some sources. It is obvious that the state can in the EU finance completely the decarbonization without feeling much of financial liability or burden. And it's quite obvious given what the state sets as a goal. The state creates conditions and dedicates some sources of financing for the modernization. Yet another important area is the reimbursement of capex and opex in part on new technologies. That's in fact a subsidy, but in fact there are subsidies, but these are the subsidies that are compatible with the World Trade Organization norms. In particular, one of the directions via which money could be allocated is an innovative fund, and it is according to the European system of greenhouse gas and quotas. The volume depends, and it's cited here, will depend on what will be the price of the greenhouse gas quotes in the EU. So there's a gap between the cost of implementation of a new technology and the cost of the implementation of an investment project that really supports the already existing technologies. So from this innovation fund, up to 60% of this kind of gap could be financed, and the max um, time frame is up to 10 years for which they get their money. And also there's a just transition fund, which is a component of the European Green Deal, which is the distribution of the money of the fund between the countries. So will depend on the carbon capacity of the economy. So the higher the carbon capacity, the more this country will be able to get money from this fund. And two conditions need to be met to get the money. First of all, a particular project should bring down the greenhouse gas emission. That's obvious. That's clear cut. And the second condition is that when it comes to the implementation of this project, as the result of that project, there should be a certain employment level, our level of jobs should be supported. And that's one of the most important things because a lot of people will be made redundant and one they will have to deal with that problem of finding people their jobs. And there's yet another instrument that today is rarely used, but in the future it might also be used to finding decarbonization projects. That's projects which stand for a joint common European interest, and that's to finance, that's to allow one to finance up to 100% of gap. So within with this instrument, with these projects, there are no limitations on financing volumes. The only thing that we need is that this project should be harmonized by at least 2 EU countries, and in turn they will have to harmonize this project with the European Commission. The volumes of financing, the allocations will be on a national level, and it's understood they will depend on the financial solvency of the countries doing one or another project. And those financial resources might be allocated as grants, as guarantees, as loans. That's up to the participants' consideration. So what are the goals of the European Union when it comes to funding decarbonization of metalworks? First of all, the European Union wants to accelerate the development of new breakthrough technologies. These are the technologies that are on a research stage, on the early stage of its development, but just to accelerate their industrial implementation. Further sources of financing are necessary. The more sources of financing, the more R&D work, R&D activities, and the faster one or another technology will reach the level of industrial implementation. Also, the European Commission wants to bring down the financial burden, and we can see the example of the funds that really allocate money to cover OPEX and CAPEX, and also the state financing of decarbonization allows one to create a low carbon market in the European Union. It is simpler, it is easier to produce low carbon, and these products occupy more and more market niche proportion, and more end users acquire these kinds of products. It's also obvious that the European Union wants to be a world leader in the area of decarbonization at the expense of state financing. European manufacturers, steel makers included, bring down the greenhouse gas emission and set a certain benchmark in their industry, which will be the sample, the norm. Andrei, it's time. Okay, that's the last slide. And according to our estimates, the EU, when it comes to this kind of state policy, will continue to stay the world leader, decarbonization leader. So we have seen that the state is an important important player in the area of decarbonization, and it will be expedient to use European experience when it comes to going along the way of decarbonization, because Europe is an absolute leader, and hopefully we're going to discuss it in our further discussion. Thank you very much for the presentation. I think we understand the matter of resources is very important, but we need to understand that we're going to hit this way of decarbonization and restructure in our area if we create the whole institutional system. And the question is not about investments only, but also trade policy in Ukraine, technical policy of Ukraine. In any case, investments may go here if other things will be dealt with in Ukraine. So when it comes to decarbonization, then judicial reform or taxation of feedstock is just as important a question as the creation of some specialized funds that might make these investments. Because at the last session there was a business representation that spoke about the thing that in many ways decarbonization and green line, green course is conditioned by end users' needs. That this green logic is that goes over to equipment makers, automotive makers, and then to steel makers. All of that moves through trade, and we understand just to stay competitive, to trade between the countries, we have no other possibility than to go along this way. But the next presentation will be made by Taras Kashka, Deputy Minister of Economy, a trade representative of Ukraine. For me, it would be very interesting to find out what Ukraine policy is when it comes to decarbonization from the point of view of providing a competitive edge of our products on the European market and also on the global market. Thank you very much for the presentation that we just heard. They're showing that the policy of the European Union is comprehensive. In other words, that's more than one program that's of that financial wallet that issues money for the modernization of metallurgy, and not only metallurgy. I assume that from the one hand we need to understand what the EU are doing, but on the other hand, you don't make a cargo cut from their policy from the point of view of both conditions and also finances. So primarily we got a basic coordinate system that the European Union, that in many ways is our role model. We indeed have made our notion to actually the situation that we are conscious that mom and dad are not so ideal compared to the time we were little. And we need to understand that in the European Union itself, that Fit for 55 matter. Today we have a great day, like our Fit for 55, like we're more than fit, right, is the answer, because our metallurgy has grown up and it went through the level of the 90s and is very modernized, very upgraded. There are some obsolete elements that require upgrading, but there are some elements in our industry that we can be proud of. The same concerns the European Union. Therefore, the first job we need to do is that we need to leave the ideal EU bad Ukraine model. And that's what they post on Facebook. Those environmental activists, advocates say that we have all Ukraine in smoke, but right after the Polish border, the air is very clean and you can breathe freely. Actually, there are some pinpointed and hotspot problems that we need to deal with, but Ukraine is not that bad of a country, as we can say. Actually, there are some recordsmen, but nevertheless, we're fit. We're fit the same way, in the same way as the European Union, and this is our main message that Ukraine doesn't need to be actually perceived as a country that is catching up with the European Union. Um, we may be the same with our nuances. If you look at the EU from the point of view of the Paris Agreement, it pretty clearly says that different countries and this is why our first um, main trend diplomacy that shows we're going with the European Union, that in this Paris Association Agreement we're being fit into the same frameworks as the European Union. So our first basic thesis is diplomacy that has to achieve such result that Ukraine and the EU are the same equal partners, everyone with their problems, and we need to help each other. The second unit is how to help. I would not talk about money proper, though we'll get back to them. We need to deal with three issues, like three directions to go to. The first one is the matter of market openness. Is Ukraine and the EU one market? Largely speaking, I assume that Ukraine is part of the European Union market, industrial market, and it's not only free trade, but that standardization, technical regulation, and the business culture in general. It's understood that the EU has an opposite point of view. Ukraine is not a EU member, so we don't care to beat Ukraine or Paraguay, like the same attitude. And we assume that now, thanks to the association agreement and thanks to the commodity circulation that we got, so we have to have the proper attitude, like to absolutely natural, but think natural part of the market, of the European Union market. And our metallurgy, where we may shoot commercials on Ukrainian metal that is built for Europe, and that will be quite glossy examples. That's a trade. The second part is what we're calling transfer of technologies. That's a specific word. I don't like it. I don't love the expression like transfer of technologies. That's what the E-Step colleague was talking about. In fact, that's a dialogue between those doing research, equipment manufacturers, steel workers, and some industrial standards. Ukraine should be at the same table. We're talking about this. And we think it's an ideal moment, an element to be part of that discussion. But we need this. We need this both for selling commodities further, and it is also necessary to support the financing. When we talk about financing, we have a nice dialogue with the European Commission, with support group for Ukraine. Katerina Maternova is talking on behalf of the European Union. So last May, Irene and I took part in the dialogue, and it was about the fact that the mechanism of sustainable guarantees that the European Commission issues for international financial institutions will be extrapolated to Ukraine, but also to private projects in Ukraine. So Ukraine may use these instruments in parallel. There's a dialogue going on with the banks, with the investment bank, with the EBRD to finance all those projects. All of this is very long-term discussion, but it is not so glossy as in the European Union. European Union think, and there's plenty of contradictions on how it all works. So basically, we may understand each other quite well. The simpler for the simpler industry like metal making, like you mine the ore, you melt the ore, and you get the metal. That's how we did our lead in childhood. If you work somewhere in the middle, you need to understand that any contract, any production change is multiple years of discussion. So we don't understand when in the world it will be implemented. The same thing happens in bureaucracy. We don't have any points according to which we can say that it is here. We have decided that 2 billion euros will be used for metallurgy. That's actually a lengthy process that's made up of many elements. That's our different projects on the implementation of directives. And here we need to understand that we need to get back to the baseline about what is going on in the European Union. The European Union, they have a so-called set of fronts and discussions between environmental and activists, consumers, business, financial circles, equipment suppliers, scientists, just to provide a joint decision, and that makes the most complicated thing because everyone is against everyone. In Ukraine, the situation is about the same, and on the international level, the situation is even more difficult because the internal Ukrainian discussion should be integrated into an internal EU discussion. And I assume that today, if we see those initiatives, then I mean the documents that were already mentioned, the understanding will be that in Ukraine should not be dealt with like the Russian Federation, unlike the Russian Federation. So if this comes true in the projects by the European Commission, to be approved by the European Commission, then it will be the first great step towards the fact that all the ideas that we invest in the European ones will be made practical. And last remark is that the only problem that is available in the middle of Ukraine today is financial governance. Unfortunately, we don't have that good level of development of the culture of providing business with support. And because we either have exemptions or compensation for interest rates, and there are such things that could be very little compared with the European Union. I assume that there will be the due climate policy and decarbonization fund, and I assume that it will be the finest example when we will be able to provide for the accumulation of costs from different resources, including, I think, taxation, because there should be a general fund in the budget to be used for decarbonization. There's a number of options, but nevertheless, I think by joint efforts, we're going to reach the right model of governing that money, because it should be, on the one hand, increase of the efficiency, which is, for example, accumulate money from different sources. And number two is that those programs, if we know about the sources, these programs need to work in such a way that our industry be able to use it, because we have lots of examples when there is money, but we don't use it because there is a number of reasons, so on. So this is perhaps our biggest internal challenge, and today we're far away from giving a clear proposal to the industry that this and this model is proposed. Thank you very much. Taras needs to go, really. So I will ask him one question. Does our government and the European counterparts that you're doing negotiations with, do they have an understanding of Ukraine's position within those industrial chains for steel industry, for other industries? Because if this understanding is present, then the European colleagues might look at Ukraine not as a competitor, but rather as a partner that could be that could replenish the European and a European player in some chains. We're not yet there because an attitude to Ukraine as towards a competitor is present, is omnipresent in all the industries. But yesterday's memorandum of feedstock on raw materials, it shows that we already have understanding that our partnership for future should first of all be present, and it is already present in the vision of the European Commission. So those challenges, because we take it as challenges, CBAM, such a threat, a carbon price, like a threat. Everything is a threat. For example, I can see the biggest threat in that package 50-55, any limitations and full ban to use an internal combustion engine, and then therefore it will be landed in here. I'm not even afraid of a heat power plant in Tripilia than internal combustion engines here. That's all but our big chance to explain that the climatic and neutral Europe, we don't need to advocate for that to achieve it by 2050. We also want it, and we're going to be there in 2050, because if somebody wants the Ukrainian, that's what the Ukrainian society wants, that's what Ukrainian politicians want, and most importantly, that's the way Ukrainian business will develop, because we can show what new, if you look into what new things have come to Ukraine industry and agriculture now, there are some demonstrative examples, and that's actually the awareness of that Ukraine is a partner is very slow, but it's coming up. We don't need to sit in our hands, and we need to keep explaining that to ourselves. Yeah, I think that we insist on the intensification of the industrial dialogue with the EU. Industrial dialogue will include this metallurgy, metal thing. Then, if not, then all the rest value-added things. If we include it, it will go. The rest of the topics will go faster. Thank you. Now, I would like to, not even last time, but every time when we start talking about the transformation of our industry, modernization, and other things, then industry is opposed by environmental advocates, Ministry of Nature, Ministry of Industry and Ecology. We're on the same side of barricades, and we, as business, are interested in cooperation. But very luckily, on the level of the ministry, this dialogue is going on. So the situation is not that bad as it is pictured, and there is a dialogue, and it looks like today's event has shown that steel industry does not look at its development without upgrading and ecologization. I understand that's reality, and the strategy of every enterprise is being built on that. For each following year, that's already real money. That's already real investment into the ecologization of our industry. The only thing important to us is the understanding of the Ministry of Nature that this process is like a challenge for all. And here we need to act together and really create that environment for all the industry, chemical, steel industry, and construction materials, so that everyone has an understanding. That's the only way we can use to go. So I would like to give this floor to Irina Stavchuk, who is Deputy Minister of Nature of Ukraine, and she's doing all those things. Thank you very much. I will start with climate change being a reality in the world, and the problem is only uh, getting aggravated. It's already plus 2 degrees centigrades of temperature, and the international policy and events to deal with that problem will only be intensified because the goals of the countries within the Paris Agreement are really driving us to 3 degrees plus. That's a reality. The climate change matter is the buzzword in the political agendas. So decarbonization is not being raised, but the climate change was integrated and is actually developing in the financial markets. So we hear from the international financial organizations, from the private investment organizations, that they um, don't want to use fossil fuel, and the projects they are ready to implement include decarbonization and the green technologies. So we need to take this reality as the one that exists, and we need to use our possibilities to the max extent. With the first ones will be the business organizations, and they will look for partners and to overcome those challenges. Climate negotiations are one of the most difficult things because climate neutrality, climate exposure neutrality to mid-century is a goal where we see a more active position of the US, EU, and other big countries. But for everyone, the practical implementation will be very difficult. I am in charge of environmental policy. I worked 2 years on the updated contribution of Ukraine, and the previous goal that was approved in back in 2015 did not stipulate any redundancies, but shortenings. But in international context, there might be some unpleasant aftermath. So Ukraine wants to pinpoint its ambitious and, on the other hand, realistic goal. That was a pretty inclusive process with work group created. All the output data was published, all the methodologies, all the calculations, and it was pretty actively discussed in the last year. Now in this summer, and we counted about 100 meetings on the level of the ministries, on the level of associations, particular business companies, so that to understand that those modelings that were made by the experts are acceptable for every sector. The climate policy is essentially all the sectors of economy. That's energy, that's industry, that's waste management, that's forestry. So essentially, that's a line of economic strategy that is investing certain levels of development and transformation. Even more important is the principle with which we go. And the first position was not actually greenhouse gas emission reduction, but also the goal was what transformations were economically expedient for Ukraine and what events and activities, interventions the government should place their most focus on, so that our decarbonization policy is stronger, people's life better, and environment cleaner. And in this context, I would like to recommend the positions of our business associations like EBAs and others. GHG emission back in 2019 was 37.6% of back in 1990, and the Ministry of Environment had a proposal to have 35% by 2030. That's a reduction, but now it's an acceptable reduction currently. And when it comes to industry, we stipulated higher emissions than lower than then for the industry. It is possible to grow by 16% of greenhouse gases from the current level. Why? Because we stipulate that industry will develop, and there's plenty of different industrial sectors around which time there should be lesser emission and lesser consumption of energy resources, while industry is one of the few sectors for the national investment. On investments, we did not plan any nationally dedicated contribution. There are no technologies. There's no hydrogen, not in energy, not in industry, and these are technologies that are already on the market. So on the whole, for the industry, the business scenario is calculated that there should be investments on the level of 33 billion euros. But if we talk about the scenario on the level of the government, the goal is bring down the greenhouse gas emission down to 29%. And so for industrial and climate policy, we don't have any, we don't set ourselves any much too ambitious goals, but we, on the other hand, we stipulate that if all these plans are being implemented, all these visions that we have had over the last month, then the industrial sector will not increase their emissions but reduce it. On the contrary, the position EBA's position was said, or maybe you will talk in more detail, but it was actually to 43% or 40%. That's an increase from the current levels. For to do this, there should be major investments into decarbonization. So we want to call out to the business association, asking them to more transparently inform about the calculations. You were as transparent as possible, and you explained all the figures. Want the business association to be just as open. And my last argument is that decarbonization and development related activities and interventions. It's very pleasant to hear from Alexander and all the things that were accepted in this conference. Last month we saw DTEC, ArcelorMittal, and Interpipe, and everyone is planning the desire to become more carbon neutral, and we as the government and the ministry are ready to work actively. Taras Kashka already talked about a certain aspects of talking with the European Union. The Ministry of Environment are also working on their part, and we're completing the development of a project on draft law to formulate projects based on the EU approaches when it comes to criteria. We're working on the concept of creating a Ukrainian climate fund. The idea is that the CO2 taxation be allocated in the decarbonization project. When we negotiate with EBRD and other international institutions so that all the money that are being gathered in Ukraine be multiplied by international costs, so that there is a possibility to fund projects for cheap money, as the European companies have. So we're ready for cooperation, for further dialogue, and the work on decarbonization will be difficult, and it's now only by joint actions we'll be able to achieve our goals. Thank you very much. Just to talk about that if the officials from the Ministry of Nature are understanding the position of business, and the business has very difficult jobs to do, and it's uncertainty. Ukraine must go down the path of Eastern European countries, not being inside that European Union and not using the already built-up institutes. So it's the question I asked Taras Kachka is very important. And the question was either an understanding that European officials will take Ukraine as not a competitor, but part of the cooperation to be that will allow the European Union to increase that in their production chains, and that yesterday's agreement on raw materials was a good step. It's understood that it's an increase of mutual dependency between Ukraine and the EU will allow the EU to look at Ukraine in the long run as a partner, and then as a reliable partner, and spread the border of institutional provision and development over Ukraine as well. Because not that I don't believe, but I'm pretty skeptical about institutes and funds that may be built in Ukraine, unless this is part of European infrastructure. Because this is extrapolated with inefficiency and corruption. So even the CLEAR project as an export insurance agency, they've been created for 5 years already with different speeds. I understand that any fund of decarbonization, that's a purely European project, and even if it replicates European practices, where is unlikely to be a working instrument, then NBV2, and that we're discussing that long. It talks about the seriousness of our intentions, and we want to take the commitments that are possible to be fulfilled, and given that's a long-term plan, and that we don't want to take upon ourselves the obligations we don't want to fulfill. It's very important, but it is also the understanding of the state where we're going and the strategy of Ukraine's development, and maybe there is no better party as in Ukraine as Kirill Kryvylap, who is head of the Prime Minister's advisor, and he's in charge of the expert group that was preparing the strategy of economic development in Ukraine. And I would like to ask Kirill by how much the decarbonization matter is embedded into this strategy. You know what I paid attention to? That here on the stage, the minimum 3 people 10 years ago worked at the Ministry of Ecology. I was in charge of the Department of Investment and Science, Alexander, and now they're back here. And the situation is similar with the National Economic Strategy. 1 year ago, they started to do economic audits for the Economic Development Director, then the like 1 year and a half, the decarbonization topic wasn't such a predominant theme. But by the time then public discussion followed and the strategy had been confirmed by March 3rd, it was like proposed that let's call decarbonization strategy because it was so dense. And as to the topic that the strategy set itself, and the economic audit showed that the country had a potential of doubling the real GDP within the next 10 years if one tries hard, and if the course will be implemented. That means real growth by 7%, ambitious pace, and it was like 3.5%. That was the projections of the Ministry of Economy. That's the ambition that the country has to double the real GDP. And what we deserve is what our citizens deserve because they have the lowest GDP per capita. While having the lowest GDP per capita, we will never build a worthy medicine army and so on and so forth. So the government is acting in such a way that they are doubling the real GDP. Now, according for decarbonization, we really have joined our efforts. We went down the way of the Ministry of Ecology, and we went down all the associations, used other different methodologies, but eventually got to the same point. And the difference was that we counted the investments together with the practitioners of the area. We looked at what activities should be done from the point of view of technology and iron, and we together worked out 3 scenarios. The business as usual, least optimistic, 43-45% is the level of business as usual. That's we're gonna get to about 12 billion euros within 12 years. And the next scenario is one whereby we invest 15 billion euros plus on decarbonization. These are the cases that are not on the table. They're not budgeted, and does make sense to invest them. We reached 27 billion investments and 40% by 1990. Even with this, so we are actually world champions on CO2 emission reduction compared to 1990, but it's not of our own accord. That's because the private energy sector, but 40% is the goal that we're ready to achieve. That's 1.5 billion euro into decarbonization every year, and there's a more aggressive, optimistic that's achieving the level of 36%. 36% to 1990, 50 billion euros of investment to particular interventions on decarbonization. And so yesterday we eventually sent a joint letter, signed jointly to the ministry, 50 billion plus 38 billion for decarbonization over the 10 years, but it's theoretically possible. But every year we should invest the money comparable to the IMF program, 10 years. That's quite a challenge. So from the point of view of the business associations, metallurgists, ABAs, and others, 45% I think is a good value. That's 40%. That's 40% is where business suggests that you restore, even if you hit the 36 and 40%. Anyway, there should be 3 conditions to be fulfilled. The first one is clear-cut regulatory stable policy that concerns metallurgy less. There's plenty of changes, and the situation is even worse with energy sector. Metallurgists don't have any debts that they accumulated. It's even a more complicated situation with the energy, and it makes 60%. Is expected to fall down to 20%. So the first condition is regulatory policy. And now let's initially describe what we're doing with the eco taxation. We need support by our international partners. And the third block is climate and finance, and that's a standalone fund. We've seen what Europe is investing. That's a standalone program because the cost of capital here is different from the cost of capital there. We won't be able to talk about the same approaches to Europe. So this is what we have as a fork, and we're getting to the same point actually in different ways, and that should be our political decision on what figure is for ambition. But that's discussion to be continued. Kirill, we're really grateful to you because what must have been done in Ukraine a long time ago, some sort of adequate economic strategy. Over the last year, Kirill managed the team, and I hope very much that the recommendations that the strategy reflects will be implemented by the government. But MVV, the approval of one MVV and compared to the other doesn't mean anything. So under the uncertainty conditions, there should be like a fork. Conditions for investments should reflect the right changes concerning CO2 emission. No changes there, no changes here. We're oriented towards by much more ambitional goals and objectives, but for to achieve them, there should be very coordinated government work. The probability of success is not that large, but we need to take advantage of it and achieve success. The government, by the results of the first 3 months of strategy implementation, has been mentioned. Agency for small and mid-sized business and so on and so forth, many other things, the law 2600, many things really equalize the conditions for all. So the cabinet of ministers is studying all the developments, budget declarations, the first 2 years. That's the framework available. And then the committee has just approved the budget declaration. That's a great step ahead. We're going to have financial frameworks for 3 years ahead, and believe that's very important for decarbonization, for greater investments. Aspects like struggling with corruption plays the same importance and has the same influence as the aspects of trade policy or creation of one or another specialized fund. And people spoke more than once that green metallurgy is not possible without green energy. Whatever decisions we make, unless we talk about futuristic projects, that all depends on how green our energy is, which is switching to EAF electricity as electric steel making, by how much the Ukrainian economy energy sector is green, by how much it will increase. And I think Alexander Tarasenko will answer this question in the best way. He's running the expert group and at the Ministry of Energy and European integration, and he used to work for the Ministry of Ecology. I went into the dark side of this, of the power. The Ministry of Energy also shares this view. We need to move towards the neutrality, not that fast as the Ministry of Nature considers. For this, we are also involved in the interventions of our government. And in this process, we have 4 major directions. The first one is strategic. We developed a strategy for energy safety. Now we're also developing a national plan for energy and climate, and we're waiting for the final confirmation. Also, we're working on the updating of our energy strategies. Another direction of energy is energy efficiency. That's a great area that will contribute to a much reduction of the CO2 emission. We already drafted a law on energy efficiency through first reading. It's approved. Also, the right national plan's been developed up until 2030. That will be approved by the government. The requirements on eco design and eco marking, eco labeling of industrial commodities is something they're working on. And renewable energy sources, pretty trendy, not very understood how to implement it fully. Already there's an investigation of hydrogen and how to transform. We're doing work to develop a concept, a hydrogen concept, and developing regulatory documents that will regulate this area. Yet another very important direction is the coal regions transformation that is directly related to energy. We know that our coal area very dotation consuming, and they want to close down some mines, coal mines. And as the result, there will be less electricity generated at heat power plants using coals. In this area, we have a national plan for emission reduction, 90 plants, but now we're doing some internal consultations, taking into account our aspiration for climatic neutrality. We are looking at a lesser number of those plants. Well, first of all, that's power plants operating on coals that we're going to be refusing, and that was already the talk of Ukrenergo representatives, that they're calculating different energy mixes, and they believe that one way to a more environmental energy will be cheaper than to save all the heat generation in its proper way. As to MEV2, we were active critics, and first of all, that was one reason we don't see where the source of money will be on the modernization. You know, the problems on the market of electric energy, to modernize the energy of Ukraine, there is only one source of investments, is that's market. So the end user will pay for the upgrading of the energy. We all need to understand that, and we need to accept this. All our ecologization will be paid by ourselves. Thank you. May I also add about the paycheck, the country with the highest level of energy poverty. Just to remind you that 4 billion is required for metallurgy, my optimistic scenario. I think this is very important that Ukrainian citizens need to understand that ecology and climate changes concern everyone. Of course, the country's industry and economy are moving towards decarbonization, and that should be recalculated for the budget of every household and every particular citizen. That's a decision of that citizen. Yes, I'm ready to pay more. And Europe has been is promoted, has gone ahead in this direction. That this matters, being conscious that this matter is important, and hopefully our citizens will have this coming to them. They will understand that's important. And now we're starting our Q&A session. Yet another panel member, Yuri Petrovsky, that never got to the rostrum. You can say right from there. Yuri Petrovsky, the deputy minister from the Ministry of Strategic Areas of Ukraine, dealing real hard with Euro integration, Euro Atlantic integration. Good afternoon, dear colleagues. I'm really glad to meet everyone here at this international forum. I think that these events, first of all, put together the efforts of business trying to do something, and also authorities who are present here, as we have deputy ministers, very honorable, very smart and understanding on how to facilitate the next steps of business. A lot of things were said, and I took part in the last panel, and I listened to Taras, Kashka, and we shared some opinions. So what I wanted to add is that we need to use European experience and look at Europeans doing so, but inside the country we're running into lots of issues. And we can talk for ages about decarbonization, but we need to talk about the internal market and what is going on the internal market. I guess Alexander Kolonkov and I, 10 years ago, we worked at the Ministry of Industry. Just to remind to everyone that we had a balance approval every year on metal scrap, talking about decarbonization and not talking about what's going to become of the metal area if the export goes up and the metallurgy is left without raw materials. I think we need to start this dialogue. And the Balance Commission were involved, and the analysts were involved in the beginning of the year, just to be more exact. And the next year, the metallurgists understood very clearly how much scrap they need for the next year, and the analysts were given the information and gathering the clear information. It might have been incredible by not credible by 100%. How much they can give of metal scrap and collect it to make the industry work. And then the difference was for the export, if it was there. So I assume that now, together with the association with the Ministry of Economy, all the structures that are related to metallurgy, we need to get back to this practice, and then nobody will have any questions on what to do next. There will be figures, and we'll be able to absolutely clearly understand how the area, how the industry will work tomorrow. If you, unless you raise this scope of issues, then in future it won't be necessary. Thank you very much, Yuri Alexandrovich. You're absolutely right. That's a very practical issue that concerns decarbonization. We spoke about the future, that one of the most important questions and risks that will still make us see is growing investments that at the pace that Kirill stipulates in the country's strategy of development. Machine building will develop as one of the sources, but now at this stage, in the conditions of insufficient investments, there's not enough scrap, there's not enough machine building. It's very important to control the scrap generation volumes and use our it in metallurgy. So as Profile Association, we went to the Ministry of Economy, to the Cabinet and strategic areas to be supported and to really have a temporary and impose a temporary limitation on scrap export. Dear audience, any questions for our... Hi everyone, Vladislav Antipov. I'm just an experienced Ukrainian citizen. My question is, on December 12th, 2020, at the International Climatic Summit, Vladimir Zelensky said that we're looking at the goal of greenhouse gas emission reduction 36 to 42%. So today the Ministry of Environment and Natural Resources suggests 35%. So it's more ambitious than the president said. So the president looks not very ambitious. And background of the Ministry of Environment and Natural Resources. We, as experienced citizens of Ukraine, very anxious about the president. And is it politically right that the ministry announces more ambitious goals than the president? That's a question for Irina. The point is that technical calculations were received by the ministry in early December, and the arguments were formed back in November, and the data was on the level of 2018 yet, and maybe we spoke about the figures that the president might have announced, and we were based on a very conservative corridor, but after the calculations, after having many consultations with other ministries, we reconsidered, we rethought, we specified all of that, clarified, we confirmed a lot of things, and another figure was proposed for the president. Okay, experienced citizen is now okay. Irina, another question. First of all, there's a strategy of low carbon development of Ukraine. Now, I would like to understand by how much this document will be practical, by how much it will include the interventions to understand where all the country is moving, just to understand, but we have now lesser risks required for investments in the decarbonization. And also another question, the market development of CO2 in Ukraine, by how much it is possible in next years, because we already have a system of monitoring and verification. Now, what are the next steps? What can be expected? And when this market will be working in Ukraine? First one, strategy. That's actually the degree of the president about approving the strategy, and now we're talking about with the Council, Security Council of the possible looks, appearance, and that will be just a framework of draft law that really lays the basis of monitoring and long-term goals and terminology. So that's a basic draft law that is available in the European Union. And concerning the particular action plan, that's most likely development. After the end of the goal is approved, there should be a detailed integrated action plan developed, or a roadmap for all the sectors, and really it will have its jobs like action plans, strategic documents, regulatory acts, economic instruments. and we can see the context. There are key vectors of economic development. There are key transformations, and a particular plan of regulatory financial investment and other economic instruments should be developed. The second question on trade system, we're launching a system of reporting and monitoring and verification. Many institutions have already registered themselves, and next year we're going to have our first reports. The monitoring, verification, and the reporting system worked for a few years, and then they switched to a trade system. As a Ministry of Environment, we can see as one of the interim stages, we can see on the one hand a higher pay for CO2 emission, but with programs and visions on how we learn to invest into decarbonization programs that concerns not only the industry, that concerns the transport having no CO2 taxation, while there should be clean transport for the municipality, and the same pertains to energy efficiency of buildings, but we are only starting to work with that, and we're even starting to form our concepts of vision, and we're going to consult and talk to business about that together with other stakeholders. Just to thank all the participants on the panel, all the participants on the conference. Couple words from Stanislav. Thank you very much. I will switch to English.
So our decarbonization forum has come to the end. Once again, we have made sure that decarbonization is not momentary fashion. It's a process for common decades. It concerns all subjects of the economy and industry in general. Today we reviewed the decarbonization technologies for steel production, but we understand, as was many times said, that it's a challenge for whole industry, energy and economy. So yes, governmental institutions play a special role in decarbonization. The speed and efficiency on their of the decarbonization process depend on their actions, and we look how Europe move in this direction. And Ukraine is an industrial country. We hope and will be industrial country and big steel producer. Once again, I want to thank to our sponsors and partners today forum. Our forum became possible thanks to our sponsors Interpipe, Ferrexpo and general sponsor Metinvest Holding. I hope that today forum has brought Ukrainian steel industry closer to carbon neutrality, and in the foreseeable future we will see how Ukrainian steel makers are close to the best world standards. Now I thank to all guests, all participants here in Kyiv, also in Zoom, in Facebook, YouTube was translation too, and all panelists here. And I invite everyone to festive reception, to gala dinner from our general sponsor Metinvest Holding. The gala dinner is dedicated to the 30th anniversary of Ukraine, 15th anniversary of Metinvest, and holding at the day of working of mining and metallurgical industry. And I can tell that gala dinner will be not here. It will be in near in Hotel Intercontinental, and our girls that help us all event will help you to go there. It's I think 600 or 800 meter. It's not a long way. It starts at 6 p.m. but everything waiting. So thank you one more time to everybody. And everyone, I'm happy to be your moderator, organizer today, and I thank one more time to all guests and speakers. Thank you. Да. Кто не понял моего плохого английского, сейчас всех приглашаю на гала-ужин от нашего генерального спонсора Мидинвест Холдинг. Он будет в отеле Интерконтиненталь, там уже ждут. Проводят туда, это недалеко, здесь 600-800 метров. Вот девушки прекрасные в белом, которые нам помогали во время мероприятия. То есть любая девушка в белом вот, может проводить вас. Значит, пожалуйста, можно собираться и отсюда, и в холле. Мы в любом случае вам поможем пройти.